Hello everyone, this is a test. Hello everyone, this is a test. Cool. So we are live. Hey guys, good morning, good evening, uh, depending on your time zone. So this is part 4 of our series of building a rack system for 85,000 docs uh, for a company that works in aerospace industry. So the uh, we'll go through the project one more time just for the new freshers. And like if you were to watch this recording in uh, I mean if you were to watch this part 4 the first time, make sure you watch you just spend some time on the first, second and third as well. You probably spend a lot of time solving a lot of the problems. I'll go through what we've done so far and what we're going to do today and what we would probably do in the next few streams. So yeah, this is what we're building, guys. This is a sample company that I created, but I wanted to mimic this has to be as much as possible, like make it as real world as possible. So we are working with almost 85,000 plus documents. I mean, when we actually working with 10,000 documents, but this system would actually support at the end 85,000 documents or even more. That's the scale we are building for. And currently we have about 10,000 documents, and this is what the entire stream is going to be. We are going to be solving for 10K, but building it for and after 10K it's probably an infra problem. You're probably this would probably even work for even 100,000 documents at scale. So that's what we're building the even more. So that's what we're building the rack system. That's our goal at the end of the day. And the type of documents we work with have is that I can quickly show you. We've actually solved all of this. We've solved, so these are some of the documents that we work with. This is from 1950s, 1960s, and this is from 1954. So a ton of formulas, a ton of jargons, a ton of tables, images, and etc. So this is what we have solved. We've in the last three streams, we basically solved formulas, tables, images, and whatnot. We hit a lot of roadblocks. And we were able to solve it in about like three days or something like that. So um, yeah. So and what can we say? So let's look at what we did work on in the last 3 days. We actually worked on, so we built the basic document parsing, that's done. Table extraction for like very complex documents, that's done. Formula extractions, we've done that as well. Picture descriptions we've done, and of course pictures are able to the model being able to understand pictures and etc. And also the entire chunking is done, context extraction etc. And right now, which was unplanned, but we still added Qdrant, um, re-ranker, and also an embedding. So also one more thing to note, for the entire document parsing, like the entire document parsing, we were actually using open source models. So using Qwen for everything, even for VLM we were using Qwen. And let's see what is that version. Yeah, so we're using for table model, we're using this. And I guess for tables we're using the 32 billion version as well. And for VLM we overrided it with a higher model for understanding formulas, because we had a lot of problems yesterday, but still it's an open source model. And for re-rank we're using, because I'm running the re-rank on my Mac, I'm using the 0.6b billion parameter version of Qwen re-ranker, and also running the 4 billion version, 8 quantized 8-bit quant version through Olama, which is the 4 billion embedding model. Now I wanted to run the 4 billion parameter model, but Olama was not available, and you would probably need I'm using through Hugging Face, so then I would probably need a GPU to quantize it. So right now I just want to run it on my Mac, so I just use the 0.6b version, and you can see the read anchor is on the side, it's working, and it does all of this stuff. And yeah, that's just literally it. If you were to if you now from this we're going to we're going to improve the code a little bit more, and then we're going to start on working the agent, where the LLM would reason through things, use the documents, use this and that, and try to come up with an answer. And we're not going to jump into code initially. We're going to take a step back and understand what we're trying to solve, who are we trying to solve to, and what are the personalities of each of our final user, like who is going to use our platform, and what is their minds, and how would they use the platform, what is their current search system, traditional search, and etc. Try to really understand a history of that particular person, and then we would want to come back, and with that good understanding, with that domain level understanding, we can, I think we'll have a fair good chance of making an agent that would actually, be useful for them. Because the thing is, I don't want to make an agent that, just basically the search. That's not the entire thing. If it'll probably be, I don't want it to be a generic search that would work for everything. I mean, at the end, that's what I want, but this is specifically for rocket science search. So not rocket science, but like rock documents, like um, technical papers, memorandums, research papers, graphs, tables, formulas, and etc. So they have a very different way of searching. It definitely won't be. I mean, the thing is that could be, we could build it into a basic search that could look into docs and get back for any docs. But I think we have a lot of metadata. We have a lot of like we can have a very good understanding of the system, the documents, the amount of information we have, and then we also could map it out, understand how the end user would use it, and try to have like a custom catered solution for them. I think we'll have a good chance and a fair chance of being very useful for them. So that's the entire goal. So we'll go through the things, but before that, I just want to make sure the re-ranker is working. um we have re-rankers, and we've also stored this on Quadrant. I will, yeah, it's using the local Quadrant for now. Later we'll change that. Dashboard. Okay, here. Yeah, so cool. So what we've done is that we are building the system that supports 85, that should support more than 85,000 documents. Right now we have 10,000 documents saved to an SSH to a VM. That's why we will do all the processing and etc. and save Coral and etc. And I've spent a few hours in the past videos in Logic. We've spent a few hours to get a sample of diverse documents among the 10K documents, because you can't look at 10K documents at once, right? And but what you can do is that get samples of each document, and you could try to see how formulas are present in a very old document, on a mid-old document, probably in the 1990s. Very old is like 1950s, for example. This is in 1954, and we've solved formulas, tables, images, etc. for a document in 1954. And we've also solved it for the very recent documents, which is sort of like an automatic work, because if you were to solve it for the worst problem, at even at this case, it does seem to work very well for the newest problem, because they're very strict, very straightforward, very simple, and etc. So we've been able to get a ton of, what do you call, a ton of sample data across the 10K documents. So these work as representations of each, a type of document, and we were able to go through each and every most of the documents of each diversified document space, from, in terms of timeline, or even types of document with a lot of graphs, maybe technical papers, and etc. And you can go through the docs probably, and in the first video you can see how we pulled it. NASA has its own API, NTRS, NASA Technical Research Space System, I think we call it. Yeah, technical report server, where you can actually use the API to fetch like even 100,000 documents. It has a lot of documents, millions of documents, I think. So we just pulled in about 10K from that, and it works uh, super well. Like the documents are really great, and we've pulled a few of them to give us a good testing data for us to build it for like proper diversified docs. Um, yeah. Apart from that, I think, yeah, we are probably in good shape, and yeah. So you can see the documents. These are from 1963s, and we've seen even 1954 docs. But these are very well scanned ones, so yeah, it should be good. Yeah, guys, cool. Now I wanna just clean up the code a little bit, and once again, the overall um the overall goal of today's listing is to understand as much as possible about the user, and try to have like a first test pipeline working with a few search queries happening with our documents and etc. And also we'll probably, yeah, I hope this will mostly be sort of like a theory sort of understanding sort of space, and then we'll probably move in to the code part. Yeah, but I definitely want to get like like very good understanding about the user before I even touch code on the agents. So yeah, so I'll be like, okay, thanks. I would like to process all the documents inside this directory. What is this directory? Sample box. And I think I want to, before even I jump into it, I think there's a lot of improvements to be done. So I think we'll work on the improvements first. Yeah, so let's take a quick look at one of the conversations we did have. I sent the project information and I think I asked source something like that, some initial level of information. So, and we had this chat on the second stream, I think. So basically, we'll just go through this. Our goal is to sort of, yeah, just refresh the understanding of what we're trying to do and, have, I think, yeah, because I tend to forget things very, very often. So I want to just, get into this. So yeah, this is what we're building, a enterprise RAG system for highly technical domain. This falls under knowledge management or enterprise search, but specifically the modern AI enhanced version of it. Yes, traditional keyword search fails because an engineer searching for thrust chamber failure won't find the 1997 doc that says combustion instability led to chamber wall breach. Yes, true. That's why we're building this in the first place. The concepts are same, but the words aren't. And plus, you'll have a lot of documents. You'll probably even have 100,000 pages. If then, how would you solve it? Is what we're trying to do. Um, and yeah, degraded document quality. And this is what we've solved in the past 3 days. This is done. We are able to accurately, with 90 to 95% accuracy, pass documents from 1954s, which is nearly 70 years, 75 years, like that is probably very, 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 very long. And technical diagrams, we've actually solved technical diagrams as well. With all of them are using open source models, not Claude. So we have used so many unique, creative ways of solving this stuff with like zebra lines, and you could check the streams. I would encourage you to do so. Um, and yeah, so this is technical diagrams are also done. Apart from that, formulas are also done, tables are also done. So that's, I mean, that sort of falls under technical diagrams. You'll have like not just diagrams, but also forms, falls, formulas, and etc. So all both of this is actually done, which is the one of I would say pretty much most of the complex part of the project. So that's done. Domain specific language, these are the acronyms. We would actually solve it after we build the search agent. This is what we have to do. We For the search, I basically want to use OpenAI Claude this time. I usually according to the documents, probably the system would be deployed in a compliant space where you can't use cloud models, but you have to use open source models. But later you can actually change them. It's not a big deal. But I want to use Claude and see how well it sort of performs and really try to understand patterns from it, which I could really match when I'm using an open source model. But it doesn't matter. Domain specific language, we're not going to fine tune them, but we're going to build a smart retrieval system for domain specific knowledge. And this is a sort of in the past, what I've done is that we use open source models, access a lot of these domain terminologies and fine tune them. So then they know what LSP would be, what LOX would be. When the user was to specify LOX, it will actually expand the query and mention liquid oxygen something, and stuff like that. So we could fine tune it, but this time I want to work it out not without fine tuning. I want to get the same accuracy by using a retrieval system on top of that. So we'll work on that. We'll definitely work on that. We'll have good. That'll be pretty fun to do it. And cross-reference documents, of course, this is what we would the agent would want what would want to do. And you can see failure report references test data, which references design specs. So you can see the space. You can get a feel of the space we're trying to work with. There is no one single truth of a document. You'll probably have references across documents, which one document could not probably won't be able to cover everything. Like one could be design script, one could be the test for that specific design, and then one could be the failure document or something for that specific design, right? So you could probably you want to probably be very open minded. The agents needs to be very open minded, not be able to search things proactively, even though it was only the test documents were only asked, but it should be able to pull relevant test or failures of documents connected to it or something like that. So it needs to be proactive depending on the sense. On-premise deployment, of course, all the processing, all the metadata processing, saving, Qdrant, everything's local using Docker and open source embeddings and stuff. Only for the agent, I'm using Claude and OpenAI for this. You'll need local embedding models. Yes, self-hosted vector database. Yes, that's what we're doing, Qdrant. And for LLM, we'll probably, yeah, for LLM, that's split in two. One is document processing, which uh, is a huge chunk of work that's that's already solved using open source models. So yeah, this is sort of also done. So we'll take a quick intro for this. So you understand your reading biopropellant systems, rockets using two chemicals, fuel and oxidizer that combust together. You see there's ton of jargons here, guys. Like if you were to mention, if the user was used to, if the user were to mention I don't know how do you even spell it. It's monometal hydrogen. Okay, cool, but it's quite hard for me to pronounce. So it's a fuel, and if the user were to sort of just mention this And if the document were to have this information, if the embedding is good, yes, you could retrieve it. But if you were to build domain terminologies and the agent knows this is the technical term for it, it can actually search through the documents because these technical terms are standards. They're like quite standard. And I can actually show this to you. It was actually NTRS technical standard domain terminologies. Not NTRS, I would say. Yeah, NASA's technical standards. Thesaurus. Yeah. Yeah, this one. So NASA Thesaurus contains authorized NASA subject terms used to index and retrieve materials in the STI repository. The scope of this controlled vocabulary includes not only aerospace engineering but all supporting areas of engineering and physics, the natural space sciences, astronomy, astrophysics, and planetary sciences, earth science. So you can see it's not just for like aerospace or rocket stuff. This the domain terminologies would also expand to much more in terms of astrophysics. If you want to solve it for astrophysical docs, if you want to solve it for, and I don't know, whatever part of whatever the sub part of the science stream you actually work with, they have a ton of, they more than 18,000, I think, yeah, easily, and they have even different versions of it. So this is free as well. This we're going to use this as well. I don't think we have an API, but we can actually download this and we can do something. So we'll actually come to this. We'll come back to this in a point. Yeah, so key metrics engineer care about. This is for an example, right? This is not, so Claude is sort of giving you an example. This is based for an example. This is not what they only care about. It depends on the query and etc. Claude did a bad job here, but yeah. Why historical failure data method? Aerospace is heavily regulated and safety critical. When certifying a new system, you need to show that you've considered all the failure modes. Missing a historical failure like they did in the last quarter is a big deal. It can delay the certifications of worsen, lead to actual failures. That's true. Yeah, we don't want this. Questions you should be asking them. Can I, yeah, of course, can I get a sample documents? What the success look like? So in actually in a real world scenario, what we do is that we actually sorry, yeah. So in a real world scenario, what we do is that we actually um like have conversations, we have conversations for more than a week. Like, I mean, conversations would just go on until the end life cycle of the project, even more. But what I'm trying to say is that we will try to, jump into calls and access as much as information as possible. Like, just have random conversations, try to see, like the thing is, because you don't know what questions to ask, you would never ask the right question. So to be able to accurately diversify the probability, or increase to at least increase the probability of you finding the right information, you just have to have really good conversations of people in that domain. Of course, you wouldn't just have conversations daily and be like, hey, hi, what do you want to talk about today? It's not like that. You want to do your research, and you would also need to be very open and very, you want to be a good listener in the first place. You want to be able to listen very much and divert conversations and come back, make notes and etc., and then try to have like a very good view of what the entire like 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 really what uh, uh, yeah, what there's nothing what is basically we just have to have a lot of conversations and try to understand the real spectrum or the real specificities of a system like this. The overall goal has to be is that you want to build a system that could save hours of their time. This is what it will be tremendously useful for them. So you literally want to care about that. You want to honest about the current. You want to be honest about your understanding as well, and ask questions. Use GPT. Try read a bit of papers. Look into their documents. For example, in the last streams, we literally looked through most of all of these documents. These are very complex, and some of the stuff I just don't seem to understand, or not smart enough to understand as well. But you can still spend time understanding docs or the space or whatever, and you can still sort of question them and sort of be open, and they'll be happy to help out, and you'll and this is more than being smart, or more than being like knowing it, more than more than your general understanding of the field. It's basically like the curiosity. It's basically about curiosity. You just have to be very curious, ask questions, and I can't stress enough. I used to ask really dumb questions, and I still, end up gathering very good information, because the people in the folks in the stream are very helpful, and that's one of the advantage you can have. They're not like lawyers. Like, I lawyers don't tend to talk much. They just don't. I mean, not talk much. They love to talk, but they wouldn't give you info and stuff like that. But this is like, if you were to ask a lot of technical stuff to like technical folks, it's like a huge advantage. You learn a lot as well. Anyway, I just got diverted to my rant. Sorry about that. Hi, Danish. What's this? Hmm. What are you talking about? Really? Really? Right. They have deep expertise and senior engineer maintenance for 15 to 25 years of professional system. Worked on dozens of certifications, but like personally investigated failures within many of the documents that are achieved. The dynamic you're walking into some computers. And also you can see a good point over here. They're precision oriented, sometimes to a fault. So engineering culture rewards exact specifications, correct terminologies, and no hand waving. When they ask thrust chamber failures we have seen in bipropellant system, they specifically ask about thrust chamber, not injector, not nozzle, bipropellant, not monopropellant, not solid, about 2000, about 2000 PCI, specifically not high pressure. Yeah. So essentially is that our system should actually be more specific towards thing. And we know the users are would be necessarily specific, but if you were to find, like, if they were to mention about trust chamber, we wouldn't wanna, like, if it's relevant, you want to look into other sources as well, but you don't necessarily want to give info on like the things that the user did not ask about or something like that. That's what I feel, just getting it in. But then yeah, we could be wrong, and cloud could just like give us a wrong example or something like that. I'll definitely sort of do a bit of research on this. But yeah, this is like good info, like honest is, like, first hand info is okay. Mm. Oh yeah, that's true. I mean, oh God. Just see this. I mean, I can see my fans are bumping up, and I could see why this is. And it's, I don't think you can see this terminal, but let me put it over here so you can see it. 334 tables extracted. 261 detected, zero missed. 113 are continuation tables. They're continued tables. We also, because like some of the tables are like, you'll have a huge table and it'll be continued to the second one, third one, and fourth one. Yeah, poor quality. Yeah, I think this has a lot of like, and this is like continued table. Can you see over here? Like the amount, this A600 fuel pre-burner is continued over here, right? And this is continued, and then this is actually continued. So you have 300 sort of 334 tables, and like sorry, 261 tables, main tables, and then you have 113, probably double them. probably continuation, continued tables, which is I think true because this document is so long. How many pages is this? Oh God. Actually, just keep going. I guess it's more than 200 pages. Yeah, so it's like a 200-page doc, I think. You can see the amount of pages. Easily 200 plus page. Cool. So, yeah. Cool. It'll take a bit of time, so we'll just spend more time on this. They're time starved and interrupt driven. A typical day for an engineer at Meridian works on 2 to 3 projects simultaneously, getting pulled into meetings, answering questions from junior engineers, dealing with client requests, and actually doing the technical work. When they need historical data, they need to know now after 4 hours of archive dive. What this means for you. Speed matters. The inference needs to be dead simple. Don't make them learn a complex query language. They'll use the you listen to 5 minutes windows in between meetings. Okay. You need two personas. One is the first one. Yeah. So one is a senior engineer called Sandra. She's 25 years of Meridian experience. Half of the documents were written, and she was there for like most of the half of the documents that were written. And then you have know where the bodies are buried. She exactly know where the docs are, and she knows, you know, to be able to search things, right? She literally knows, um, like where to search and etc. Has a mental map. A relationship with technology uses what works, ignores what doesn't, has many seen revolutionary tools come and go, comfortable with command lines and old systems. We're just trying to understand personalities, right? We're just trying to do like personality assessment, not assessment, actually, like trying to understand, just more about the user. Hopefully, I can understand more about hopefully, I can understand more about the systems, maybe, what we need to build. Um, Okay, what she wants, find me the thing I vaguely remember exists, validation that her mental model is correct, a way to transfer her knowledge to junior stuff. Okay. And also, so there's also another junior guy called Marcus, and this just personality is like 3 years, very new, very, very tech savvy, probably used a lot of GPT, probably is very good at prompting. Um, yeah, and probably if a query in case for the worst case sort of fails, he'll probably assume that it uh, it uh, it was probably an issue with his prompting, and will probably go back and improve the prompts and etc. and sort of do give a chance to the system. He'll definitely do. You can't expect that from Sandra. Will the judge the system? Does it help him good competent? Yeah, just like how I use Cloud Code. Can he find things without bothering senior staff? Yes. Does it help him learn the domain? Hmm. Yeah, because he'll be very curious. He'll be very curious to like I because there'll be a lot of documents, right? And if he if he wants if he probably we can put this way. He could be very curious about a lot of things, and he wants to read papers that is not part of his day job, but he still wants to sort of go through some of the old documents and see what the research has been done and etc. He probably used the system for curiosity as well. How he'll judge the system, how he how to win him over. How to win him over. The emotional undercurrents. What if we miss something again? I miss failure. Yeah, yeah. This is good. The emotional undercurrents. So, in our example was that in not in our example, as we were talking, is that one the main project was did mention that they missed something in their yeah. Last quarter, they missed a relevant failure mode during a safety review because the historical data was buried in 1997 test report that nobody knew existed, right? So they want to be very cautious because they're working with, I mean, they're spending a ton of time, energy, um, resources, money, and etc. building a system, and then if you miss even a single and a rock and I'm not a geeky guy in this rocket space, but I do understand. I'm very passionate towards the space. I understand a little bit of information. I would like to like to talk with people, be more curious about it. But end of the day, they're working with a highly expensive, and the space is very expensive as well, and high and time consuming as well. So you need to get everything right. There is no next time we'll do it sort of thing, even though you get a chance to do it next time, but in the try should be 100% accurate. So there is no way the system would probably be used to yeah, the system isn't just convenience, it's risk mitigation as well. So it's not about just finding information, but it's also making sure that this information is very right, and the information is not just right, but it's also uh, expansive. Like it's also not expensive, expansive. It's also, it gives a, probably the information is not just from one document or for a query, but it's also from many different documents, many different sources, and very diverse. So their risk is sort of mitigated because they're coming across a lot of information, in each query or something like that, and that could open up, more research or more information, which could lead to better risk mitigation at the end, because information here is very core. It's not just, table, it's not just one formula, it is a formula like that, it's sort of like a deal breaker for them. And of course tables with a lot of information and etc. Cool. I think the processing is going on. We'll have the final soon. Cool. I know it's in somewhere. The current 4 to hour search process, 4 to 6 hour search process is demoralizing. Imagine you know what you've seen in relevant report. You spend half a day not finding it. You give up and recreate analysis which already exists, or worsen, you miss it entirely. The pain you're solving is a demo, which process your faces finds in 5 seconds. That would have take up to 4 hours. Yeah, I would say it's like in minutes, not like 5 seconds, but probably like more minutes or something. Probably like five, less than 2 minutes, probably 2 to 3 minutes, because you need to spend a lot of, depending on the query, of course. If you want to do like a deep search, it, it'll probably, if you want to do sort of like a deep search, it'll probably be more than 4 or 5 minutes, maybe even 10 minutes. Maybe you want to, like get a high level document sort of info, it could be less than a minute or two. um cool, cool, cool. Yeah, and anxiety, the old guard is retiring. It's also about yeah. So a system, I can you can just note some of the bullet points over here. A system is risk mitigation. It's also knowledge preservation, but also um yeah, it's preservation or and yeah, those are the two like main sort of things a system would need to solve. But also like be supercharge the folks who are very curious to not just curious guys. I mean, maybe I'm just putting this in a wrong way, but it's just that you want to find the right information as much as expand the information as possible that could exist in diverse amount of documents, and you want to be safe and accurate about it. This is where sources sort of play a good picture here. So they'll how to use the system. Engineer opens searches, types questions, get perfect result. Starts big, bioprotein failures, gets over to results. We have 200 results. At consider Babylon of 25, find some changes. Oh, this report reference is another one. Follow references, find actually what they need. Skim through. The system needs to support this iterative refinement process, not just one-shot queries. Yeah, because I think they are used. That's why I want to understand this person is that they're very used to. These guys are quite used for to search through keywords, and they're very good at it as well. It's not like they won't get information. They'll definitely get information, but they have to do the analysis and sort of spend extra time to see if it's relevant or not. That's what our system would mean to do. But at the same time, we're very like a lot of the agent systems or the system that I've built is that it's very agentic. You ask a lot of questions, you give given more information, and the agent goes back and it searches a lot of things and come back and etc. But here I get a feel that sometimes people might just for biopropellant failures. Uh, and yeah, what what the agent would probably do is that, come back, follow up question. I could find info on that, but probably like what year do you want, or is there any constraints or extra stuff like that. Or I just think we don't need to be as we don't need to get everything right now, like in terms of like a memory of what we need to do. But I think it should be able to, it should sort of also support very minor info, like stuff like this, like biopropellant failures, failures failure 2000 to 2000 2000 psi. Because what they're trying to do is that they're just trying to find the right documents in the first place. And then once you find it, it'll probably like, do this for a change and check if this is doing this, check if x is y or y is z, or does they match or something like that. That would be the next query. So I shot is that this entire system, the goal is to be agentic, that's what we want. But traditional people are very used to searching like this, so we should also have some way of, you know sort of giving that feel of a traditional system. But uh, uh, I mean, just to make sure they're not lost, right? That's the only goal. Yeah. In case they just want to see a few docs in a high level. Yeah, but we'll think through this. First, it's agentic part. We want to follow. That's what our system is there for. If they want to use keywords, let them just go and use their traditional keyword search. But the system that we're building is for a different sense, which is also very powerful as well. Okay, this is a nice one, to be honest. Accuracy by transparency is divided by is over effort into past appointments. I mean, Claude just made that up, guys. Like, questions to ask in your interviews. Walk me through the last time you had financial historical data. What do you, what do you do when you can't find something? How do you know when you search thoroughly? What would you do in your system? What's your worst experience? So then I was like, because I can't ask this to Sandra, right? So I was like, be in your shoes, be in the shoes of Sandra, and accurately sort of answer the question just to get some perspective. And I did answer. Yeah, so essentially, I mean, of course, you can go through this, but the understanding is that um, assuming this was actually a real world conversation, what we're trying to do is that she's mentioning that in 3 weeks ago she was trying to find some historical data that was buried 15 years ago. She just she this she looks into different folders, looks into projects, and this like very like keyword searches like chamber, and then expand on more documents and check for references. Some documents would reference other documents, and she would check that, and that document doesn't exist because it was only partially scanned in 2015, and it's probably in a different building or a different drive or a different folder on a different server. And then she probably waits about how much 3 to 4 hours, and then she has to jump into a meeting, and then she's lost in something else. So at the end, the flag was historical data, search incomplete. But that data I mean, the data does, I mean, the data would probably exist. She couldn't find it because yeah, it wasn't streamlined, or it was lost somewhere. But just assume if the system, if all of those if you're lost somewhere, you would never know. You probably have like 50, 70,000 documents, and you have different wordings, different file name. It's somewhere. You would never know. But assuming that she copies and pastes and our system processes this, I would know. I would probably want to know is that I would probably want to know. That's what I'm going to ask Claude, is that in case if our agents were to solve this, how would it solve this, and what actions you would need to take, and also what would her query be like. I want to understand what would she query, and how a system would probably go through stuff and understand, etc. So we'll just give this shot a bit. Yeah, so it's assuming that our system is only doing like retrieval only. Like it's assuming it's not an agentic system, and it's a retrieval system where you put in something, it does semantic search and just retrieves it, and then she adds more information, stuff like that. But I want to be clear here. So I'll just be here. So please note that our system is an agentic system, which means it'll think like a human. It'll search through things, read it, analyze it, reason through things, and then if it finds new information, it'll search for those. It'll be basically it's not just retrieval. The 50% of the problem is only document parsing and retrieval. That's something that we have solved. But the next part, the important part, is that it should be intelligent as a human being, and not just a human being, but then be someone like Sandra, and then have that domain intuitions to search into the right place, make really good search queries, and then also reason through things, understand problems, switch paths, and really be, and that's what we call it as an agentic system. 50% of the work is only processing and hybrid retrieval, but the rest 50% is actually analyzing stuff, understanding it, reasoning, and going back and forth, asking follow-up questions, and being open to new information, and having a note or a task list or sort of to-dos to track what to be done, what more I have to research, and change them as it goes, and etc. That's an actual uh, that's an intelligent agentic system. We are not building just OCR, or just like what do you call a retrieval system. We're not just building semantic search. We're building semantic search is just on par a very small issue. We're actually building an intelligent agent that thinks like a person like Sandra, and then sort of, perform searches and do a ton of things to be able to give her a right response. So see, Sandra doesn't need to search for keyword sort of thing. She can just mention it as if she's talking to a smart human who has access to all of the 100,000 docs and remembers all the 100,000 docs, and could give her and find the information and synthesize it and give her a report or something like that. So that's what a system, that is what we're trying to solve, to be honest. Yeah, so we have to mention that because it's assuming that we're building, because you can see the diagram here. Metadata extraction, embeddings, and the vector. We've done the guys, we've done this. This is all good embeddings. We have metadata extraction, we have OCR, we have chunking, we have everything. But the thing is, that's only 50% of the work. We're trying to build a smart system that just goes beyond the question. We're just trying to be just like we're just trying to clone Sandra and give a and like 10x intelligence or 100x intelligence giving access to. That's what we're trying to mimic. We're trying to mimic Sandra. Sandra doesn't search. Sandra asks. Yeah, exactly. Asks, and the agent thinks. Let me replay. What Sandra actually wants. She doesn't type a query. She talks to it like she talk to a brilliant colleague who has the photograph memory of every document. Exactly, that's what we're building. A brilliant colleague who has photographic memory of every document. This is what we're building, guys. This is such a nice, uh, what nice way to uh, put this, put what we're building. Okay, so I'm working on a safety search for a new. So yeah, you need to also they give in background context as well. That'll really help the system. Like I'm working on a safety scent for a new Apache kicks motor, bipropellant NTU/mmH, and they're pushing chamber pressure to 2000 psi. I'm worried about thermal energy at those pressures. I know we've seen issues before, maybe around the Europa program. Can you find what we know about this? That's it. That's the input, natural language. That's where that, the way that she ask a senior colleague. What does the agent do? Introducing. Okay, so let's go through this. It'll be nice. So okay, let me understand what Sandra needs. Context. Numeric classification, chamber message, and all this stuff. Her concern: thermal margin at elevated pressure. She vaguely remembers Europa program, some past issues. What she actually needs: historical case of thermal issues in bubble chambers, failure modes we've seen, any design guidance or lessons learned, specific Europa program data if it exists. My search strategy. This is very good. We should have search strategies for it. Search for thermal management institution by and this would launch, and this would be one, like you could think of it as a sub agent that will look into so many docs and then comes back. Because yeah, that's what I think we should do. Search specifically for Europa program propulsion issues. Search for high chamber pressure. Look for failure analysis related to any findings. Check for design guidance on thermal margins pressure. And let me start. And it didn't yet start. This is sort of like a plan of this is the context, this is what she needs, and this is my search strategy. And let me start. And then it begins. So first, it's going to go through, I think, the historical cases, or maybe the thermal issues in bipropellant systems, and thermal margin erosion bipropellant chamber, high pressure. Now the thing is like this the query will be much more better because we're using domain terminologies from NASA thesaurus. So yeah, retrieves 37 potential relevant chunks, agents reading through the results, document TR repairable. This looks directly relevant. The test 14 was aborted due to chamber research anomaly. Post-test inspection showed thermal margin exceedance at throat region. Chamber pressure was 2,350 psi. That's close to Sandra's 2,000. Yeah, that's close. Yeah. So I think it's the reasoning sort of trying to understand, trying to map different things. Important. The document references MAR FA distinct for detective failure. I need to find that document. So it does go back and sort of does a lot of keyword search, or maybe like because something like this MA FA, you could do keyword search for this. You might directly find the exact document. You could also do some semantic search as well. Either way you'll try to pull this. I could also try to use method. If you have a lot of metadata, so it can probably process a lot of metadata as well. Oops. I think open router is failing a bit. Anyway, it's fine. We just wanted to just run it. It's okay if it fails. Document high pressure bipropylene chamber test. Old document 1997 discusses thermal analysis indicating margin revolution above 2200 psi. Recommends material change for sustained operation. Okay, this is good. And you have document this. Might have current design guidance. Let me flag this to read more this carefully. Updating my task list. Search for thermal margin issues. Find, and now it's basically updating its task list, meaning it's sort of like a to-do list where it needs to now. It so basically did the search, and it found that so you need to search for this specific document, which is very critical to search, and it needs to understand that or perform a search for that, and will come back and work on the rest of the other ones. And of course, like, you can have systems that can work things on, like, you can launch subagents parallelly for certain tasks, and if certain tasks are dependent on certain tasks, you would want to sequentially process that and process parallelly. you know I mean, at the end of the day, it's just a subagent. You just have to generalize a subagent that makes a decision. For example, in this particular to-do list, this check if there are related injector issues, the Europa report, right? What it can do, this could be a parallel subagent that's independent, that does the work and comes back. Look for any other failures, analysis high pressure, and you can do stuff like this. But the thing is like this, for a domain like this, just see the initial task. This There was about 5 task lists, right? And this and if you were to, like for example, oh sorry, I'm just blabbering here. There was like 5 task lists over here, and if I were to scroll down, you can see it was working on the first one, and it discovered new information, and this is very good information. MARFA slash 2008 2008 slash, it needs to check this document, and upon checking this document, it might find even more information which can be used for the next consecutive searches. So if you were to there's probability, guys. There's different system. You can launch sub agents which is independent, and it will still give you good results. But I think for a system like this, I would like, information is so dense, information is very, very important, where you would need to wait and understand or gather information on the first few tasks, and use that information or the learnings from that in order, before even you work on the next task, sort of thing. So I see this sort of domain to be as important as that, where information could lead to very different outcomes and etc. So I would definitely yeah, I don't think I'll probably have parallel stuff going on here. I want it to be sequentially. Even though 3 out of the 4 tasks could run parallelly, I would still just keep it open and keep it, not keep it open, I'll keep it sequential. Is that you would never know where new information could lead the path, would probably even change the entire plan. If you found better information, if your entire plan was wrong, because you have no synthesis, you have no information at the high level, you're only creating the plan depending on the user's question. But when you find information is when your plan becomes more solidified, where you update it and it works on things. So for now, we'll assume that we are going to sequentially process all of this, right? New lead, inject the pattern is got thermal issues. I should search for this too. Yeah, following the lead. Thing is, like, it doesn't need to update the task list often. Like, you do, like, as you come with new information, you don't need to come back again and keep on updating the task list. And you don't need to do that, because it'll just make things a lot of it will make the entire plan much more complicated. The thing is, you need to have 5 to 6 to-do lists. That's the main goal. And then you can have each to-do list have its own sort of notes if you want to, but not even notes, because we're doing everything sequentially. It just needs to have a notepad and also to-do list. So for each task, what information did you come across? What are the new information? Does it affect the other search, or maybe notes or whatever, and etc. That's what you need. Just keep it simple like that. And it doesn't need to come back and just info MARFA. And then afterwards, if MARFA, the document, I guess it's a document, it references something else, you don't need to come again and update the plan. That's not the goal. I think you can hear my fans. So I think, yeah, generated 1553 chunks in reading order. Good. And it's, yeah. So this is working, I think. Thank God. Because anyway, at the end, we'll be processing this on a GPU. Sometimes with the models and stuff, I might run away with them as well. Run usage. Where we have to GPU there. It's fine. I do this week. And do you have agents internal reasoning? Find it. Yeah, this is gold. The root cause was injector related, not just chamber related material. Santa needs to know this. It means that the thermal margin issue might not be solvable just by material selection. The injector design matters. Design. Okay, so this is from 2008. She probably forgot. This is very good use case, guys. And this is very random that we just, we just asked it, but this information is very good. Um, um, and yeah, and this is what our system, like, that's what we want to do. That's the whole goal of the agency system. It's not just finding finding words on, like, it's not finding certain keywords and just bumping up files, or just finding basic text and giving her information. It's just trying to do that thinking work of that particular person, like an expert person in the domain, and then sort of try to solve that as well. That's where the agent goes in the extra mile, the extra step. And that's when you can actually call it an agency system. If not, you just can't call it an agency system. It wouldn't make sense as well. And yeah, should I go deeper into the injector analysis? Let me assess its relevant to Sandra's question. Yes, if the root cause was injector related, she needs to know what the injector consideration was. Yeah. And this is Claude, guys. That's why you can see this sort of. The thing is, because I think let's use Claude for this. I can and Yeah, I mean, even on the only thing the Claude could even generate a use case like this is because you can understand this domain very well. And I think if you were to use Claude, it'll probably, yeah, perform in a like something like this. For something what we see in the test case, it probably performs something like even better with our changes and etc. So broadening the search and faithful broadening the search, and you can see this is also, so this is so you so this is, I would say, this is one theme of an agentic system, not an agent system, but then the system that we should design is that you have to make sure the agent is not sleeping on anything, meaning it's not just focused on one single info. It should also be very, I would say it should be very, very open to understanding and finding broad information through broad search requests. So you can also see this pattern in Claude where you were to ask some question. Some of the times it uses the search tool to find launches subagents to find launches different keywords, different information for the same thing to find. You probably launch like not five or six, probably like two or three sub agents or something like that. The only goal of it is to get a direct hit, just to see if you can get a hit of some information. Because re-rankers and etc, it's all good, but end of the day, it's not a big difference. You would only, like, you would never find the right information on just using a re-ranker. So it's just good, nice to have sort of thing. But this is the most important sort of theme or concept of the agent that we need to do, is that it would probably, so this is where the parallel sort of search could be useful, where you use the search tools to, try to use different keywords, use different meanings and stuff like that, perform 10 searches to somehow find a good hit. Like, we assume, just, pray that we find the good information, and we could 90% of the time, because it's very broad. We're doing 10 different keyword searches, not keyword, different searches with slightly different meaning for the same query, or intentionally for what we want to find, but on a very broad space. um, Doing 10 queries, not three, I would say 10. Yeah, 10 is a good number. We'll figure it out, because we have to manage context as well. But yeah, if it gets a good hit, and this is where you'll find good information. For example, see here, find something that I wasn't expecting. Different program entirely, but similar. They saw film cooling breakdown at 2100 psi. Different injector design, but same underlying physics. The pressure temperature coupling changes the boundary layer behavior. Wait, this is a theoretical study on combustion stability and injector geometry interaction of off-nomical mixture ratios, published in 1996, author was Richard Chen. This might be a document Sandra mentioned she vaguely remembered. Let me read more. Yes, this paper discusses how injector geometry affects chamber acoustics at elevated pressures and predicts the thermal margin issues with pressure exceeding 2200 psi due to changes in acoustic model. This is important. Sandra needs to see this paper. It provides a theoretical foundation for why 4400 psi is a risky problem. updating my search list, stuff like this, and let me check for the success cases. Sandra needs to know not just what failed, but if anyone made it through and work it out. And yes, and if you're working in a big company, and if you were to use like not just company documents, you'd probably, and not just for company documents, I would say, but also any research papers, technical papers that you already it's all the technical papers which already exist out there, right? You would want to see what you were building is probably you want to find any issues that were related to it, why this failed, because I'm building it again. For example, this 2000 psi, it's 2400 psi sort of thing. But did anyone succeed with that? Like, but the thing is like this, you can't from the cloud to saying when a user when a questions comes in, make sure you also find the failure modes or also be proactive about the success modes. You can't do it. But what you can do is that just trick it to use its own domain training intuitions, because this stuff is already trained. What we have to do is that be proactive enough, but also try to be very broad. Have 20% of your tool calls or whatever is dedicated to 20% or 10%, whatever the number is, dedicated to finding broad stuff. Just be curious if you might, because one single hit of an information would just change the trajectory of the entire search. You might find very new information that the thing is like the user would not never know to ask it for. Like, you would never ask if there are any success failures, or because in the company's knowledge, she's only working for 20 years. The company is running for 50 years maybe. Like, they probably had some success with something like this in a very small level before she did join, but you would never know to ask it in the first place. So stuff like that will only be possible only if we have like a higher rate of a hit, like higher rate of hit rates. Like, hit meaning like you just hit and come back, you don't reason it, you just hit it and try to see if something is relevant with the relevant chunks. This is where the re-rank would be useful, and then you see the first 10 or 20 chunks, and yeah, you'll. So the things like this, what you want to do is that you don't want to this is where you want to use very low chunking threshold, not even 500, maybe 256. So then you can see 20 small hits opposed to big paragraphs that are only 5 or 6. So that's what I would also encourage that we do here, is that we I mean, of course, right now the paragraphs I don't think we have we have a minimum chunk with 200 150, I think, and then the maximum will be max 2000, I think, because each paragraphs are sort of dissected and kept into prompts. But we can just split it up, it's not a big issue. But what we really want is that we want to have we want to see, at least in the hit, so broadened search hit rate, we want to see 20 to 30% of minor chunks. So then it could, and very different chunks as well, not from a single document as well. We will try to prioritize it in some way to access more chunks from very diverse spaces, hoping that some hit would lead to, in a worst case, a good outcome. We're just trying to increase the probability. We could never know, or we can never prompt it in a we can never prompt this stuff to Claude, and it'll be confused, and it'll just for everything it'll just do the same thing. So what we need to do is that just keep the space open, let the information that Claude sees be the guide opposed to our prompts, right? So that's what I'm trying to say. I'm just trying to explain this to you because I also want to process this, so I remember this stuff, and I can just go ahead and actually, I think we should have recorded this. It's fine. It's fine. I mean, yeah, cool. Yeah, that's what we want to do. And these are like basics that were broad and such and etc. Not a big deal. Looking for counter evidence. So, by problem system, agent reasoning, reading the details you've used. This is exactly what standard shows high preference, but requires specific design changes. The Europe of failure was with all the design practices. I now have a complete picture, historical failure, what happened, theoretical understanding of the pressure. I think I have enough to give Sandra a comprehensive answer, and it gives a beautiful answer. So the list of historical failures, things that she didn't even ask for, a successful high pressure operation which ran at 2500 PCI because of an improvement on a design change. Cool. Like, this is, yeah, if the agent were to do this right, it's um it's a game changer for people working in the aerospace domain of space, right? Yeah, cool. So the cool. And also one thing I want to say is that just this is not a trick, but you can actually, use this, is that instead of let's say you're building a system for, solving financial docs, solving this or solving that. Instead of asking, I'm building an agent for standing alert. What do you think the agent should do? How the agent could be great? What are the things the agent should do? I'm building for this company. And if you were to ask all of this like pure crap, the agent will just spit out uh, like very incorrect stuff. Like not incorrect, it will be correct, but it will be not on par of to what you want to build. It'll be like, make sure the agent is proactive, make sure it knows this, make sure it understands the user, make sure this, that it'll probably give you like a system prompt. Or what you should do is that you basically have to trick Claude. You have to not say Claude that you are going to build an age. Not, I mean, you have to tell you're building an agency system, but more than that, what you have to trick Claude is that you have to put Claude in a scenario. Like for example, you would put like what we did. You have a personality called Sandra. This is what we are building. This is what who we are building for. This is how she searches all the traditional information. This is how day-to-day life would be in a company. This is how irritating it should be. Irritating the search to current traditional systems are. This is what we are trying to build. Now I just want you for this specific query, how Sandra would, fire a system like this, and how would the agent and how would the agent think, or how would Sandra, sort of follows up with her? How would the agent find new information? How would the agent, changes part? What would an exact answer be? So you just instead of asking, you just give it a give it a different perspective, and then you just see how well a system. This is just sort of like a simulation basis. Simulations would always work. You're simulating a user asking a question, and then simulating how a great system would actually answer. In that case, instead of Claude giving you points, it wouldn't give you points over here, but it'll just give you it won't directly give you points, but indirectly you can reference this simulation, and then you could actually note down the points like what we did with broadening search and okay following the lead. So what we need to do is that simulations work very well if you're trying to solve to a domain that's very complex. You can't do it in a single go, and I wish that I can do it for like 20 or 30 people like Sandra. So very different queries, what the agent system would do. I just want to see what it does. So it will give you this is what the agent is doing, this is what the agent is doing, this is what the agent is doing, sort of like a simulation. And then seeing the simulation, you have to literally see the simulation to find patterns. And then what you can do is that you read 20 to 30 simulations, and you grab a solid pattern of okay, if we have to build a system, this has to have this capabilities, this is how it has to reason, this is how it has to fire off hit queries, this is how it needs to broaden search, this is how the domain intuition should look like, this is how the agent's thinking pattern should look like, this is how the agent should be. You're basically trying to design an intelligent sort of an human, guys. So you can't literally prompt it to find this information and just use vector search to find information and find. That's not the whole deal. Those are basic stuff. Yep. And system prompt plays a huge role here. You can have all the tools and stuff like that. If your system prompt is very filled with a lot of examples, filled with a lot of stupid information, literally nothing works out. Your system prompt has to be not too long, not too small. It just needs to spike up the domain intuition. I will show you an example here. When we do the entire system, you would get a chance to see how the thing is, at least I think we should be successful at this, but let's see. We might hit some roadblocks, but that's okay. But it's always good to do simulations. I do a ton of simulations I used to work for, not work for, I used to work my old startup for legal stuff. So we were building some legal agents. So, so what I used to do is I used to do Claude, give like in Upwork, you have a lot of guys putting, right, I want to create this contract, this is my company information, all of that. What I used to dump is that I used to give that information, not like that specific job template, and then let Claude first of all generate personalities. This is this guy, and also like Zoom conversations, like test recordings, right? Like assuming that the user talked to the lawyer Jeff, and then client Raj. They both are talking. This is the conversation, and etc. And then what we do is that run simulations. The first simulation is that conversation is going through on Zoom and etc. etc. It's conversation phase. What you do, you get the summary of the conversation, and then pass it to the second phase using the whatever the second phase would probably include all the important information from the call, and then trying to research through legal databases, do this and that this and that, and then you have like a good legal research done. Third is creating the document. Fourth is actually talking with the client and then making changes to it. 4 to 5 phases of one single simulation. We call this a simulation. And what you can do is that you can create simulations we're using real world stuff. If you go to Upwork, you can see these guys have a lot of questions, and that's ethical as well. I mean, you're not selling anything, or you're not making money of it. You're just trying to see some real world use cases. You can take Upwork. It's a very good space to get real world info on any specific products even you build. They have, because they are hiring people. They're hiring people who pay that. They're hiring people, and those posts are usually well defined because they're paying money for it, stuff like that. So that's how you can make real world simulations. And if you were, and not just simulation, what you should do is that sit and this is the hard part. A lot of people just jump into the code and they just write some tools, some basic prompt, and assume it works. But the most important thing is super accurate understanding about that person. And that's why I guess it's already 1 hour or so. We didn't touch any code, nothing. We are just going through the user and just going through a lot of understanding. So yeah, understand as much as possible, understand the user, and run a lot of simulations. And yeah, do a lot of work before even you start code, guys. Have that, solidify the understanding, and then jump into stuff. Sorry for my rant. I think I talked for a long time, and I think I did want to, like, I just wanted to mention all of this information because these are like super important. That's why I think we're still processing documents. It's fine. Cool. I think I do want to start now. I think I have a good. So agent's mind, look at this. The agent needs to embody Sandra's domain knowledge, what pressure range is world is normal, the thermal emerging issues, blah blah blah, and all this blah blah blah. Retrieval method. Start broad, follow leads, track what you've searched and what remains. Look for primary sources, not just summaries. Seek counter evidence and alternative explanations. Know when you have enough. An analyst synthesizes ability, connecting, finding across documents, identify patterns, separate root causes for symptoms, and provide actionable assessment. These are the themes, or maybe the personalities what we want our agent to have. Okay, so now I also, just for a sake, I also want to look into a different scenario. Thank you, Claude, this is very good. Now I would like to look into a very different scenario that is also quite yeah, how can I put this? Yeah, that's also quite, not quite, yeah, this is very good. Now I just want to look into a different scenario, but not something like this, something um maybe we can look at how a junior would use it. Or maybe no, because if you were to design a system for a senior, it will still work really well for the junior. Because if you were to solve the highest problems with all this agentic stuff, and like the, I mean, the nature of it is that if you were to solve it for a very complex problem and it make it as generalized as possible, you'll tick the boxes to all of the below, mid, simple, different sort of problems as well. So that's a good spot. We don't need to rework for each. Maybe you might have certain differences, but yeah, as long as the system could work for a very complex problem, it'll definitely work for a simple problem as well, as long as it doesn't overcomplicate a simple problem. So this is Claude. I think Claude is very good. I would like to see a different query, a different scenario as well. So I'm just hoping Claude would be Claude would give me like a different scenario, because I don't know like, I have a lot of unknowns. Like I have, so even like, if I didn't sort of simulate this, I would never know something like this even exists. Like I would never know that the agent needs to do like see some successful failures and etc. So the thing is, like, I have no information at all. What I'm trying to say is that instead of asking what are the unknowns are, and which Cloud could hallucinate, and I would understand merely nothing. I just want to see scenarios and just pattern match things, and then like improve my understanding based on simulations. So I just want to see different query, and I hope I could discover some new information which could be part of the same part of the personality of our agent. So yeah, I like different query and different scenario as well. And I hope, hopefully this should be an important one. The only reason I ask for a different scenario is that it will be just to make it broad, and just to make it make just to understand different aspects of different search or whatever. So just trying to be just trying to be open here and random. Yeah, actually, just trying to be random here because I don't have a goal here. I'm just trying to read scenarios. I have no goals here. Yeah, so let's just I think, yeah, I don't want to repeat everything. You guys can see my screen, read it off. And also, if you see this particular, I can just initially see that this was to be some sort of like a plan which you wanted to create. But see, this is very different. It has what happened, my initial assessment, possible causes I should investigate, marks real questions. This is very new. My search strategy. We had search strategy even before, but you can see this is very new. This is very new, and this is very new. So what we need to do is that we need to make sure the agent, sort of, um, yeah, s- includes any. Just try to be as accurate here as possible. So we don't need to hard code stuff like if I scroll up, we shouldn't hard code stuff like have the key findings. Sorry, not key findings. Have the context, what actually needs, what's this search strategy. Have these three stuff in your internal reasoning, and then come up with a plan. Like we can't like we shouldn't do that because it can differ by scenario. What you can do is that you just can't try to encourage it to come up with a reasoning or a boiler template that would probably include all the important points, things it needs to look into, any notes, any plan, or any important thing that needs to be part of the same plan, or maybe even what if if Sandra was to work on this, or who's that, Marcus was to work on it, how would he probably have a notepad or a note down book or something like that, note things down, stuff like that. So still, I'm not really clear on this. I'm not sure how I'll do it, but we'll see. When we work on it, we can try it. First, search the obvious query. Yeah, so this is search here, internal reasoning, and I think I'll just go through them. Hmm. Yeah, this is also a very good use case, but I think this will also require markers to specify any documents that they've already worked with. For example, this is sort of bluntly saying that um, that's what I think. I can be wrong. We just ran a hot fire test on RCS Truster for Artemis contract, RB alpha class, standard, whatever this stuff. Everything looked nominal. So it basically need what they might have some supporting documents for it, right? So it needs to markers probably needs to select all of them and send it. That would actually work as additional context because there's some data it needs initially, I think, for a query like this to initially work on. If not, it'll just spend time on searching those right documents and trying to find them. Um, so this is where what this is where you can use a lot of um, you can use sort documents by relevancy, meaning that you can to find the stuff that Marcus created, just try to see the author who, by metadata it is Marcus or that's created in the last 20 days or the last 50, 60 days, and then try to find that that's quite relevant. So depending on the query, it'll definitely change, but yeah. Yeah, but this is okay. Not I didn't expect. Yeah, I thought it'll be like a very different scenario, but it's generally different. And root cause assessment points to NTO temperature below optimal range. This is a test procedure parameter, not a hardware issue. Post test inspection is being conducted to confirm. Yeah, that's good. Yeah, so they probably have to confirm that. The phenomenon has been seen in previous resolved with no hardware impact. Yeah, one will dig into the areas impact and search for formal test procedures to check whether NTO requirement actually says this helps. What's different between this is a research certificate, diagnostic some sensitive. Yeah, figure out what's going wrong quickly. Agents approach, hypothesis driven, focused investigation. So yeah, agent you can see agents approach. We need to. I think we should have agents approach as well. Like recall like for a question, so it needs to, so like we cannot influence the agents, like we can't influence the agent to directly like or spontaneously work on things in a different way. But if you were to decide what the approach should look like, for example, for Sandra's query, it should decide it's an exhaustive search and should follow all the leads. Marcus query is probably hypothesis driven and then focus investigation sort of thing. So so basically that's like a personality, right? You just spike up that sort of uh yeah, basically give you more intuition to make the next right step sort of thing. We can try it. If not, we can just remove this agent's approach. We can just try and see. I feel like we should try. Domain reasoning to the for a basis risk regime. These are means output structure. Yeah, that's different. Agent's mindset is a researcher, but this should be a troubleshooter. Again, you see a lot of personality shift here. So agent's approach and agent mindset. Um, and the nature. So I think these are the stuff that the agent needs to generate when a query comes in. What's the nature of the query? What's the goal of this? What my approach should look like, and what a correct mindset should look like. So this will influence the you wouldn't know it, but I've seen patterns here. I'm only talking because I've seen patterns. If you were to the if you have a mode like researcher, it'll influence certain type of soul calls. It'll influence certain types of reasoning. These are stuff that you can't necessarily, there is no one way of there is no the right way of saying this is what it is, but you can feel it. You can feel when he does the tool call, you feel when he do the research reasoning, and so you can feel that this mindset is definitely influencing the tool call structure or the way of tool calls on the reasoning and etc. So just a minute guys, and some MacBook. Sorry about that. Cool. Yeah, that's what I'm saying. So the agent different thinking modes. Notice how the agent approaches differently than Sandra's query. For Sandra, cast a wide net, find everything relevant, synthesize into a historical picture, look for patterns across decades. For Marcus, form a hypothesis quickly, test it against evidence, maintain alternative explanations, give actionable dynamic steps, help him prepare whatever. But you can see different thinking modes, different approaches. To be honest. So another key difference is where agents domain intuitions look at what the agent knew without searching. NTU has high freezing point. Expansions of the thing is like this. Uh, if you were to use an agent like Claude, you can highly depend on the intuitions, could be right. But if you are using like or Qwen or something like that, you'll just make things up. You just and then you'll have a you can't depend on intuitions. Like you can't depend on facts from intuitions. You can depend on like the approaches and etc. You can't verify any facts. Like it'll move. There's a good 50 to 60% chance they'll definitely hallucinate. So expansions and the reason you can see Quinn's reasoning is also filled with hallucinations. So what I used to do is that we just there's no way we can't do anything. We just restrict the agent to only work with the source documents. For example, NTO has a high freezing, but even if it needs to sort of validate it, it probably look into documents or sort of some database or something, something to validate this. Not for everything, like it wouldn't go ahead and validate each and every intuition. So each and every like sort of assumptions that would still you have no way of controlling it. So yeah, no point talking about it. So expansion or as a processing system. This is domain knowledge layer that makes the agent feel like a colleague, not the search engine. Without this, the agent would written documents. With this, the agent reasons about it. Yeah, this is very good. Thank you. Now I would like to see another different scenario, and this time we'll actually use the not Sandra, the other guy. I guess we talked about the junior one. We'll actually leave the name. Okay, this is junior engineer. Okay, right, right, cool. Now I would like to make sure that this is a real world scenario. I mean, of course, everything is real world, but I just wanted I should mention. Uh, yeah, thank you very much. See this. I would like to see make sure that this is a real world scenario. Cool. Yeah. Yeah. Still have no goal, just being random, hoping that I'll discover some stuff. Okay, the process is still going on. All the chunk will. All chunk. Okay, it's all the chunk stuff. Charge. Okay, so this is some happens all time cost. Yeah, so it's 11:15 a.m. Sandra just got an off design review with a customer, commercial launch provider. The review is going fine. The customer chief engineer dropped this. I saw the space next had a propellant installation wheel failure on the recent mission. Process search took out the wake seat and they lost altitude control. With design uses a similar valve architecture. How do we know we are? So I think guys, we're all there. This is the because it's a consultancy sort of company that they're working on a lot of projects. So what we should do is that we should let them create a project and they let them drop relevant documents and save all the project related documents in that folder. So then the agent doesn't need to always look into, if there's like 50,000 documents, it doesn't need to go ahead and find the relevant stuff always in that among 50,000, because 50,000, like you don't need, even though we have 50,000, it's just for a safety, guys. None of the time the agents is looking at like thousands of docs at the same time. Only when you find historical cases, if you want to look something very different, you want to do it. But most of the time, I guess initially once the project is going on, you would probably want to have a space where you drop in all the documents for that certain project. So I can feel like you probably have to have a project thing going on there. Um, yeah, so actually we should have noted all of this down, guys. It's my bad. We actually run it through the agent later and just create all these points, but I think we should also designing the agent. So we just call this heading to agent. We create for the work memory. We have to look at the scenarios, and we need to have a way add documents related to the project. So something like cloud projects. So it's saying you're using a similar architecture valve. So which means it needs to look at what the architecture is in the first place. So project docs will, just save a ton of time here because it's also a very time sensitive query. I need to understand what happened to space next, whether we've never seen anything like this or whether the system is actually vulnerable. I told them I'd get back to them by end of day. The system is a biopropylene RCS for a lunar lander, NTO/MMI. The isolation valves are solenoid actuated. I think they are from Moog, but I need to check the design docs. So in this case, I think some any I think in this case, Marcus who's Sandra would probably drop in some documents that is related to the failure. So I mean that's because you have to base it on something, right? And then you'll have that info. You don't need to search up. I hope so. Search for Luna and the RCS gen docs. Search for propellant oscillation logic. Search for process search. Search for solar and valve. Look for any valve qualification. Okay, it found the customer system. So it doesn't, so I don't want to, because if you go to search Luna Land RCS biopropylene isolation valve design, you're gonna get a ton of results. But the thing is, you're probably working in this project, you'll probably have this customer stuff in the project. We'll encourage the users to add this. Like the users should also do some support here. So we need to, and because they'll find like proper information, they don't want you don't want to waste time trying to find the right information if you know where the right information is. This is an efficiency sort of thing. So it found it. This, like, we don't need to do like a general search. We have to do it in a search in the projects in the first place. So anomaly close operating procedure like this valve seated material upstream projection. Interesting, no surge space that could be relevant. It also found document. This compares several valve options to move was. And also you can see that I don't we shouldn't the thing is these documents are very long. If it's more than 10,000, 20,000 tokens, we should do rack inside the documents. So you get, I mean, it's a very simple thing, but the thing is that also you should do it in that contained space. That's what I'm saying. Because sometimes it might have different terminologies and etc. And you might, so this is where the symbols will be useful. Like we did parsing, right? But we had one way of pulling all the symbols in a given documents. That would be in metadata. So in case symbols do exist, it can use that symbol sort of words to do search, and that'll be even more, what do you call, it'll give even more accuracy over here, because if you were to search for the exact symbol, you'll end up in the exact space. So normal operations with this and this and this, if a bot sequence is, and also giving the you should have also have the agent to be able to or should have got this. Yeah, whatever. But agent should be able to what is agent should be able to, yeah, look into adjacent information. So let's say it finds this information, uh, and what it needs to do is that it needs to read the entire section. Now, because we have metadata, because we have metadata, we can just group them by the section header and get all the section. If not, you can read the first 10 or the last 10 chunks. Because we have metadata, it's quite interesting because we can just do like a one lookup and then save all the stuff. Phase 5, look for prior analysis and mitigation, water, hammer pressure, such like that. And you have this information, recommended information, document, study. The study is directly applicable and explain why the specific frame. And should I look for any success cases where this was managed? Is there any quick calculation? Actually, I think I have enough to give standard a complete picture. Let me look at positive note, any cases where we're finding a positive precedent. So I think this is sort of, I don't know, maybe the past use case was looking into positive notes and etc. It's trying to find precedent, but I don't know whether agent will do it because yeah. In worst case, even if it was not proactive, right? Santa could be like, just go ahead and find me any successful precedents. How do you spell it? Precedent is precedent. Yeah, I think that's how you spell it. Cool. And the customer has legitimate concern, but it's residual. Okay. I found the quality bit on including internal memo analysis. There's both good news and bad news. During lunar extension, specific service section pressure. Your customer division and check the Artemis landing. The Kappa found the trade study noted the design relies on Orion heritage for water, but when I checked about Orion document, Orion has surge suppression. Your customer designs doesn't. Orion uses 0.0.40 surge suppression of its upstream each isolation valve. Testing this showed this reduces pressure spikes from 4.2 to 1.6 nominal, keeping transient high below. The customer inherited the valve, but not the protection scheme that makes it safe at high cycle rates. Yeah, this actually happens in consulting, and you would also know this is a consulting company, right? So you'll have a lot of Q&As with what went wrong, what could go wrong, etc. So you should be able to support, so those queries as well. Yeah, I think we have enough info, to be honest, guys. So, but this is still going on. I think it's with a lot of failing of open route API calls for sure. Oh. All right, guys. So I think we are ready. We have a very good understanding of what we want to do. We've spent, I guess, nearly 2 hours just going through this and trying to see use cases. I would actually do like another 10, to be honest. And I'll do it in like very different Claude chats, not this because it'll follow the same pattern. What I'll do is that have fresh chats, but I do have like enough information and with my past stuff and all that I think I can just easily, not easily, but then just just build something fairly easy, fairly workable in the first few hours, I think. So yeah, I think we can do it. I'm just gonna get my lunch and come back. So let's generate something for. Hey, Dayara Patel or something like that. Thanks for your comment. We're basically building, as I did reply to your comment. I just saw it now. We're essentially
Dayara
building
Patel or something like that. Thanks for your
rack system
comment.
that
We're
works
basically
for.
building, as I did reply to your comment. I just saw it
Hey,
now. We're essentially
Dayara
building
Patel or
documents
something like that.
which
Thanks for your
exactly
comment
we're
that works
basically
for.
building,
And
as I did
yeah,
reply to
which
your
also
comment. I
should
just saw it
be
now. We're essentially
run
building
of the
documents
queue.
or something like
So
that.
we
Thanks
just
for your
go
comment.
through the
We're
list
basically
for
building,
and
as I did
yeah,
reply to
which
your
also
comment. I
should
just saw it
be
now. We're essentially
run of
building
the queue.
documents or something like
So
that.
we
Thanks
just
for your
go
comment.
through the
We're
list
basically
for
building,
and
as I did
yeah,
reply to
which
your
also
comment. I
should
just saw it
be
now. We're essentially
run of
building
the queue.
documents or something like
So
that.
we
Thanks
just
for your
go
comment.
through the
We're
list
basically
for
building,
and
as I did
yeah,
reply to
which
your
also
comment. I
should
just saw
be
it now. We're essentially
run of
building
the queue.
documents or something like
So
that.
we
Thanks
just
for your
go
comment.
through the
We're
list
basically
for
building,
and
as I did
yeah,
reply to
which
your
also
comment. I
should
just saw
be
it now. We're essentially
run of
building
the queue.
documents or something like
So
that.
we
Thanks
just
for your
go
comment.
through the
We're
list
basically
for
building,
and
as I did
yeah,
reply to
which
your
also
comment. I
should
just saw
be
it now. We're essentially
run of
building
the queue.
documents or something like
So
that.
we
Thanks
just
for your
go
comment.
through the
We're
list
basically
for
building,
and
as I did
yeah,
reply to
which
your
also
comment. I
should
just saw
be
it now. We're essentially
run of
building
the queue.
documents or something like
So
that.
we
Thanks
just
for your
go
comment.
through the
We're
list
basically
for
building,
and
as I did
yeah,
reply to
which
your
also
comment. I
should
just saw
be
it now. We're essentially
run of
building
the queue.
documents or something like
So
that.
we
Thanks
just
for your
go
comment.
through
We're
the list
basically
for
building,
and
as I did
yeah,
reply to
which
your
also
comment. I
should
just saw it
be
now. We're essentially just
rack
go through
system
the
that works
basically
for
building,
and
as I did
yeah.
reply.
Oh yeah, I think re-rank is already done. Yeah. So this is the plan, guys. Next, what we're gonna do, come back and design the initial. So before even we jump into this, I just need to Claude do the right amount of tool calls, reasoning, streaming, and all that. Get that boiler template working in the first place because if you don't get it right, it'll probably cause some errors. I want to do the boiler template code, and then we'll come here and see how we want to influence the agent. We want to change the prompts as we move on. So we're not gonna stick with try to get the prompt right in the first day, but we'll just give it the first thing. And I'm already processing a few documents so it can Qdrant, and then we'll do the agent based on the few documents we already have locally. And then once everything is done, every aspect is done, tomorrow or the day after, we'll probably index and save all the 10,000 documents in our VM and then expose it via an API and then use it to our agent. Okay, so that's the plan. And yeah, that is the plan. Cool, guys. I'll see you in a bit. All right, guys. Seems like the process is still going on. So let's see what's our run message and etc. As you can see, it's just all right, guys. So just a quick recap on the things what we really did was we were trying to understand we were trying to understand what we are building, who we are building for, the personality of the user, and what sort of queries would they run, and what would those really look like. That's what we were doing, right? So cool, and we got a good understanding. And yeah, so I would just want to get any. So I think Claude should be able to generate a good system response. So I'll be like, uh, so this is good stuff. Thank you so much. Now, all of those three scenarios are basically a lot of domain intuition is going on. So I think I want your help to design me a system prompt that doesn't hard code information, that doesn't give examples and stuff like that, but it'll basically encourages the agent to use its own domain intuitions and training. Also, I would like to encourage the user to the agent should also not encourage, but the agent should also have the initial. I would say I would just put this. Uh, so I also like the agent's internal reasoning. We can assume that this could be some sort of plan or something like that. Once the user comes in, I want it to do the understanding and situational planning, and they should also include the to-do list as well. And then afterwards it's the matter of going ahead, performing the searches, updating the to-dos, and if you have new information then you update it, and if you and go on. So that's the general purpose of that's sort of like the gist of what we want. Of course there'll be tools and this and that, but for now what I want is a system prompt that encourages this sort of we saw three use cases which was very great, but I don't want to hard code anything, but still I want the agent to really come up with stuff like this, which means I need to provoke its internal domain intuition. So draft me a system prompt that could help do that. So you should give me like a decent system prompt which we can use it as a boiler template going on. um yeah, we just send it and see what the system prompt would actually look like. Yeah, I think okay, and you can see so many images, guys. So many images. Ton of images for sure. Yeah, we're working because I can see a ton of images here. Yeah, and I think this is doing 141 figure 141 images, which images meaning figures and graphs and etc. And this is from this document. I'm sorry to I jump here and there. I'm just trying to this is how I work, so that's why we didn't find them. Okay, yeah, of course. This is sort of like a presentation, right? You can see so many images for sure, right? Cool. I want to see yeah. Hey, this looks good. Let's see. You're an expert researcher embedded with Meridian Aerospace, a consulting specialized in satellite profile systems. You have access to Meridian's complete document knowledge spanning 25 years, approximately 85,000 docs, including test reports, this and that. Your users are engineers who need to find information, understand historical context, diagnose problems, where response on time pressure. They will speak to you as if they could speak as a colleague who has preferred recall of every document in the archive and deep domain expertise in real. Okay. How you think? You're not a search engine, yeah. So we're basically scoping its personality right now, and I want to just slowly take it over and just show it to you. You're not a search engine. You're a reasoning agent who uses search as one of your tools. Yeah, that's very important to be frame it. When a user represents a question or situation, engage your full domain knowledge and engineering intuition before and during investigation. You understand the physics, the failure modes, the regulatory context, the operation realities, and unspoken concerns behind what users ask. Very good. Your knowledge of aerospace engineering, propulsion systems, material science, fluid dynamics, and related domain is part of who you are. Use it when you use it. When a user describes a symptom, you should already be forming hypotheses based on your understanding what typically causes such symptoms. When they mention a pressure value, you should have intuition about whether that's a nominal or concerning. When the okay, this is too much. This is basically sort of like an example on the above three cases. The demonstration guides your searches and help you recognize relevant information when you find it. Your working process: when a user brings you to a question or a situation, you work it through methodically. First, you understand the situation. Before searching anything, think carefully about the use what the use actually needs. Consider what is the explicit question, what is the underlying problem, and etc. All of this stuff. What would be a complete genuine useful answer? Yes, this is where you don't hard code things. You because you the question could be very different, and the usefulness or the goals of the question could be very different, but they're very interconnected. So what you're trying to do is that if the question is this, you would use the first principles, guys. That's what you want to do. You want to use the first principles, which are usually simple. You want to understand what context do we need. What could a right answer be? What are the edge cases we want to solve? That's where you start. You need to start somewhere, and this is a good place to start. Then form initial hypothesis based on the material, what do you expect, and all of this stuff. Plan your investigation. Create a clear plan what you need. Maintain a working task list what captures what questions need to be answered, what searches you need to perform, what hypothesis you're testing, what you've completed, what remains open. The task list is a living document. You will update it as you learn more. Search with intent. Each search should be a purpose connected to your plan. You're not keyword matching. You're looking for specific types of information to answer specific questions or test hypotheses. The thing is, I'm just reading this out, is that it could definitely miss. If, for example, as we saw over here, this is an example which we need to correct it. We just it seems like it was quite incorrectly included, and so I just want to go just read it loud and just see whether this is whether this sort of is it a initial good sense of a does this have a good sense of an initial system from. That's it. And a search should have purpose connected. That's good. Construct searches that reflect how information you need might actually be described in documents. Use your domain knowledge to anticipate technology, synonyms, related concepts, and how engineers actually write about these topics. Read, analyze, and reason. When you find documents, actually engage with them. What does this document tell you? Does it confirm the contradict with your hypothesis? Does it reference other documents you should find? Does it raise new questions you hadn't considered? Does it change your understanding of the situation? Very good. Think about what the document means, not what it says. Documents often reference other documents, mention related incidents, or hint at additional relevant information. Follow this leads. The most important finding is often not in the first document you will find, it's in the document references. This is also superb, like a very good follow-up lead, sort of an prompt. Be alert to document IDs or reference numbers mentioned in text. Related programs or projects that might have relevant history. Names of people you might have written other relevant documents. Time periods when relevant work was done. Cost reference specification, analysis, or test data. Update your understanding. As you learn, update your task list and hypothesis. Mark completed items. Add new questions that have been emerged. Reprioritize based on what you've learned. Abandon lines of inquiry that prove unfruitful. Pursue unexpected leads that seems unpromising. Know when you have enough. You have enough when you can give an user an answer that addresses the actual need. It is grounded evidence from the archive. Acknowledgement what you found was what you didn't. Provides appropriate context and caveats. Gives them a path forward. You don't need to find everything. You just need to find enough to be genuinely useful. Very good. This is very, guys. This is very good. I would say it's even not a starting point, but generally in a production system prompt, this is very good. Your system prompt should not be a list of documents. It should be synthesis and answer that integrates what you found into a coherent response to user's actual needs. Structure your response around what the user needs to know, not around the order you found things. Connect the dots, highlight what matters, and provide your assessment when appropriate. Include source documents so the user can verify and go deeper. Now the thing is, source documents, what we can do is that we already have bounding boxes, we already have managed sources. So what we'll do, we'll just provide the ID with all the chunks that comes in. So at the end, when the final response comes in, probably the model can just do like a sort of explanation markup, some sort of symbol, and put in the ID and close it, and then we saw it as sources, which then we also have to say, still you have to say, because you know what, the document, you can't show everything as sources, like everything the LLM read, because it could probably read, I don't know, 300 400 documents, let's say. you don't want to show everything as sources, but only the conclusion, or maybe what the you can ask that from the LLM itself. So we don't want to do the hard work there. And this is also, I think it's very important. I just want to spend some time here, which shows the principles. You use the expertise, you know things about aerospace engineering, propulsion physics, failure modes, testing practices, and engineering culture. Yeah, this is influencing the personality, guys. This knowledge helps you search smarter, recognize relevance, and provide better analysis. Don't pretend you're starting from zero. Think like the user senior that you think like the user's senior colleague. You have the knowledge and the archive access. What would be useful? Experienced colleague do this with this question. They wouldn't just dump search results. They'll think about it, investigate, and come back with an actual answer. Important questions. Oops. Important information is often connected. A test report reference a failure analysis. A failure analysis references a design spec. A design spec references a qualification test. Pull the thread until you understand the full picture. Yeah, this is also right. But one key what do you call a note here is that because I want to limit this to have 300 or 400k context. At least for this to be useful, we have to have at least 300k context. And if it goes above that, we have to do some sort of compact, but I think 300k context should be enough. I don't want it to read the entire documents unless it's, how can I put it, unless it's under 25k tokens or maybe 30,000 or something. Some documents, for example, here you can see images, how many images are being processed. Not sure how many images are being processed. Yeah, so see 141 images. If you were to pull the entire doc and read, that's just so much of noise and irrelevant information. So what we can do is that maybe some of the times Claude can come across documents. So I'll note this down here in case we don't miss it. Mm, yes, so I'll be like, some of the time Claude can come across documents, and it what it can do is that once or in any point of time in any given checkpoint, oops, Claude can read like documents which are quite long, and just to not explore the bloat the context in a given checkpoint, maybe in 100k, 200k, 300k, we can do one single reflection step to see whether the current documents that are present is, do we actually need them, or are the summaries more than enough for us to continue for the next step. Some of them could be okay, some of them you would need the entire coherent documents. Some of them we've already based assumptions based on the documents, so we don't need it. We'll store it as a checkpoint or save that checkpoint of documents or whatever in a different space and then come back. We can still do that. So it's essentially what we're trying to do. We're just trying to be smart with the context here, and also smart. So better very focused, minimal context basically leads to a lot of basically not like basically doesn't confuse someone. That's it. So consider what's not said. Users often don't articulate things. A question about a failure might also be about defending a design decision. A request from a historical data might be driven by anxiety about missing something. Understand the real situation. Be appropriate skeptical. Heritage doesn't mean identical. Verified doesn't mean truly analyzed. Closed action items might have been closed prematurely. Part of your value is catching the gaps that others have missed. Look for counter evidence. If you find three documents supporting one conclusion, actively search for documents that might contradict it. Look for cases where things have worked out, not just where they failed. The users said this is also, I think, yeah, counter evidence prompt is okay, but seeing success and failed, maybe for this specific scenario, it could be useful, because when you test something, either the rocket is the test or the propulsion system is a successful test. If not, it's a failure. So you have two dependable outcomes. So then this prompt becomes relevant. But if you were to give this to someone in astrophysics and dump in documents in astrophysics, or maybe something just electronic engineering or life sciences, earth sciences, whatever, and then this becomes irrelevant, because you might have counter evidence, but you won't have any, whether it's failed or test or counter evidence. It's basically like assumption. So for this system, it's okay, and we're building this system, so this is okay. It's completely fair. Respect time pressure. Sometimes the user needs comprehensive historical analysis. Sometimes they need an answer in the next hour. Calibrate your investigation to the actual situation. Admit what you don't know. If you can't find something, say so clearly. If your confidence is low, say so. If there are important questions you couldn't answer, flag them. The user needs to know what the gaps remains. And yeah, this is also good in your voice. You communicate as a knowledgeable colleague, not as a search tool. You can say, I think, I recommend, this concern me, or based on what I found, you have a perspective informed by the expertise in government. Maybe this is too much, like it's sort of influencing too much of, the output, like based on what I found. You can just say you're a knowledgeable colleague, and you just give it a personality rather than this. So I'll be like, I guess for this, I would uh, I would like influence personality rather than hard coding stuff. Yeah. And be direct. Engineers value clarity over hedging. Yeah. And this is what the advantage we have is that we analyze Sandra and Marcus' personalities, and with personalities, we can understand they value clarity, even though if you go to say, I couldn't find this information, or my assumption with this is very limited, instead of assuming things and coming back wrong, which will hit back, will fire off. So you have to be very okay. But for any other stuff like most of the stuff I've designed, like agents are like quite in regulated or maybe even complex stuff, like legal, not complex, but then uh, very like uh, like very complex stuff in terms of not documents, but complex in stuff of assumptions. You can miss something and you can be wrong. That's what I mean. So then when you provide documents, briefly explain why each one matters. Don't just list them. On searches, you have an access to retrieval system that can search document archive, use it as a tool. So the thing is, like, this specific search system would be quite is going to be quite the thing is going to be quite different, to be honest. What we're going to do is that this is okay for now. Just to designing an agent, we will have one search tool, but this search tool itself should be quite detailed. So for example, for now this is fine, but what we need to do is that the search system will have different search strategies, and depending on the type of task, we can inform, or we can influence the search strategies. And there could be very different search tools. It could be documents, it could be sort by timelines. So what we're trying to do is that we'll try to use the metadata and our document processing as much as possible, and look into those pipeline and what those provides us, and then we'll try to come up with a search tool or search tools that could basically, that's one of the reasons that we are trying to that's one of the reasons why they spend so much time in document processing, is that when we do the agent and when it comes to search, we can use all of the stuff like metadata search, timeline, graphs, tables, key elements, uh, and formulas, latex, and whatnot, right? So that's what we want, that's the goal. But for now, this is okay. I'm just adding this as a note. So then I know that I have to change this back when I come. So remember, the user came to you because they need help thinking through a problem, not because they need someone to operate like a search work. Because we might just remove that. We might not need it. But it's okay. And why this from this? What this from this unlocks domain intuition by specifying it. The model already has knowledge from training. This gives it permission to use it. And before searching anything, think carefully, form initial hypothesis, maintain a working task list that captures this task as a living document, encourages yeah. So these are the not personalities, basically sort of themes of the agent, right? It uses domain intuition, nothing's included. It without yeah, it establishes genuine reasoning pattern, which can be influenced by in domain intuitions without like hard coded examples. Um, and yeah, encourages lead following, demands habits, and all of this stuff. And optional structured thinking formatting when working on a problem. Yeah, understand, you don't need to think in this way. I mean, we can just because you don't want to modify the thinking. You don't want to think like this or something like that. Let's not do it. The training data would do it, and Claude can handle it quite easily. What we can do is that we can have tools to um when it bases its own understanding and stuff. What it can do is that save that in notes, and then save the to-do list completely, so it can update and do whatever it wants, like using those tools. Apart from that, I guess we have a good decent start of a system prompt. And yeah, we can just start off, to be honest. I think this is still a couple of requests are failing on open router, I think. It's actually processing 466. Oops. Thing is, all the models, embedding models, re-rankers, and everything is running on my Mac. You actually would prefer if it was to run on a GPU because it's yeah, because Mac is not efficient for this. Some packages would be very slow because they're made for CUDA and not for like not for a local Mac system. Almost out of memory. What I can do is that if there's like if there's like 3,000 chunks, that's more than enough. 2,300 chunks, probably like 5 to 10 docs, complex docs with a ton of tables, images, and etc. That's enough for now, just to start off, just to pull in information. Because later this doesn't make sense. We'll probably run all the 10K docs on a VM, not in this. It's called one. Oh, I think, yeah, I think it should be done quite soon. So it should be done quickly. We will don't we're not dependent by it, so let's not wait for it. It's just my PC is my Mac is sort of lightly lagging because every damn thing is running. Guys, 17 GB of swap used. Nothing is going wrong. I don't know why it's 17 GB. Olama is 5 GB. And actually, we don't need to. Why do we need Olama? We're running. We don't even. Why are we even using Olama? Oh, because of the embedding model from Olama. That's 5 GB. That's why. And then swap is 16 GB. Damn. A lot of data in Python. That's the thing. I guess we are having a lot of we're loading that in memory, Python memory. I think, which is all the documents and everything. It's not clear. I think once it's saved on Qdrant, we're probably having a list of arrays of that info. Large arrays, yeah, for sure. Yeah, that's why SAP is 16 GB. Mac will use sometimes heavy. Which means you're overcommitted and performance will suffer. Yeah. Okay, we have an issue then. When we deal with document processing, we need to take care of this memory stuff. So this is a good note. What I'm going to do, I'm going to cancel this for now because I'm going to design the agent and this is not needed at all for now. And we'll anyway process this on a GPU. So I'm just going to cancel this. and I should see a huge drop. There you go. Yeah, okay, cool. Yeah, we actually had memory used 7 GB. Yeah, that is a lot. Very inefficient, but it's okay. Cool, guys. I'm gonna add the context 7 API because I wanna look into Cloud Docs. The DMCP. DMCP API key. So I just for a bit. All right, so DMCP is connected. Mm, yeah, so like what I'll do, I'll launch a new cloud instance because we have a lot of memory over there. I'll be like, sure. This is progress. Actually, I would say I would need to update the progress file. I forgot to update the progress file yesterday. It's called development. Yeah, development plan. So usually you don't need to do it, but I usually do it because in case in some I don't know in some point I miss I don't know in some point I miss what I'm working on, or I have some sort of I stop the project for a week or 2 or 3 or 4, whatever, maybe a month, then I come back, they have no clue what I did, what was the progress and stuff. Plus also you can reference whenever you start a new chat to Claude, you can basically reference saying this was the progress made. And if you want to reference a file like this, you don't need to like, you'll probably have most, for example, include the information that official, we basically had this issue, we solved this stuff like this, summaries, a lot of summaries like this. Claude could basically take a look at it when essentially when we work in maybe when we work in a new conversation, or maybe something like that, it can connect all the memories just to help us and also Claude to gather more evidence and memory depending on the stuff we have worked on. So this file would, I usually have a lot. I have phases and I have phase one, phase two, phase three. These are for the stuff where the scope is well defined and you work on milestones and etc. But this is something I want to take this sort of dirty approach where we, not dirty approach, but yeah, just improvise on things and work on what I feel we should work on instead of following like a proper development plan. Yeah. So you can see this, basically this file is quite Not project info. So development plan. It's called unified. We work with document processing, table extraction, formula. So instead of cloud searching through all the code, you can just look at this file and it's mostly accurate, right? So I'll be like, thank you. So now let's go for a new conversation with Claude. Make sure to understand what we worked on recently. And I'll be just adding this. This is more than enough. Make sure to understand any relevant code that is needed. I don't think it needs to, but yeah. Next, we'll be working on the agent. I want you to design the initial skeleton agent. We want to use Claude for it. It's actually Claude. Use Claude for it. Um, yeah, I would say fire off a sub agent that analyzes Claude's docs using context-7 MCP, and yeah, write a skeleton code that has a very basic sample system prompt, a couple of tools, and also Claude being able to call multiple tools and providing a final output in stream yeah, in a proper in a sing in a how can I say, in a single go, something like that. Whatever, I just want it to work, the initial skeleton to work, and I also want it to be streaming true, which means that you need to also take care of the streaming. So make sure to look. This is a bit tricky, so look at Claude's docs on how it handles tool calling with streaming, and whatever is necessary for it. For me, guys, even designing the agent and doing this complex, not complex, but yeah, quite complex. This is like figuring out this stuff on document parsing, everything's okay, but writing this basic skeleton code, looking at docs, Cloud stock and the streaming, that's way complicated. Tool call is different, the streams are coming in different format. So I just, let Claude handle that. And yeah, just click on enter. So this is a fresh conversation. Good thing we have this development plan. We have all of our progress uh, documented over here. We should give Claude a good idea on this. Yeah. Yeah. So this is okay. What else do we need? I'm just trying to see if I can work on anything parallelly. I can work on domain, again, terminologies parallelly as well, because this will take some time, but it's okay. I think, yeah, I think we'll start working on domain terminologies parallelly. At least we'll have some decent progress made. And I had some conversation with Claude very recently about it. So I'll try to fetch it. Yeah, it's aerospace and domain fundamentals, I think. This be solving images and this thing. Actually, I had a conversation. Maybe it was a conversation. Okay, so I think I had one. Totally forgot. Maybe it's just a conversation that we had with Sandra, like with personality checks and etc. We'll check it in that. Okay, it's here. There we go. So your first question is aerospace terminology standardized? Yes, extremely standardized. So I was just researching on whether aerospace documentary are standardized because one document could mean one very different. One document could basically mean something. Uh, one document could actually mean something very different in a very different document, because if you see a lot of business documents, they have their own company acronyms and etc. Like some all bullshit. So I don't want this to be like that. But I guess what it was like, you'll probably have, like, they have 18,000 jargons, like standard documents by NASA. And if you were to share any NASA stuff, SpaceX is working with NASA, and either you're working with NASA, or sort of like any standard like not connection standard. No, sorry guys, I'm actually blabbering here. So basically is that you have companies. SpaceX follows their own company names, whatever the policies they have, not policies, but some standard structures. They have their own standard structures and etc. But when you come out and you were to publish a technical paper, or if you were to work on a contract with NASA, if you want to do like that, you should, follow those. That's what I understand. You should follow those standardized templates. And also these are technical terms, so most of them are very much standardized. Like SpaceX wouldn't need to invent anything for the for most of the natural or already used, or already what do you call, are already used, but like this actual standard, they will probably not change the standard, so it's going to be the same. And NASA has thesaurus, we can use it. 18,000 standard terms, term definitions, synonyms, broader narrow relationships, and etc. And if the user query was what affects impact, so impulse in cryogenic engines, because we have impulse, we can actually get in ISP, LOX, and PC expansion ratio, whatnot. So these are, you can do it in two ways. Like you can, if you were to specify ISP, you can pull in impulse. If you were to specific impulse, you can pull ISP, something like that. Either way, you're just trying to make sure that those jargons are right to do the better, to have a better retrieval. So model reasoning with vocabulary. And now the thing is, there's going to be 18,000. So if you're using an open source model, you can fine tune it. You can fine tune it and really get a good results. I've seen that. But here we're using Claude. So we have to build a smart retrieval even before he hits the query. So what we want to do, and we want to use some sort of very small model to do it. Um, that quickly, given a query, predicts what the right reasoning could be and sort of uses a rerank and quickly gives it. And it should be a very small reranker, like a 0.6b model. And because these are acronyms, right? You don't need to be, the latency should be like merely like a couple of seconds, maybe like 1 second. You put it and you get it, and next you go for the query. Because you might have so many different terminologies, and you're working with um, a set of 18,000, and 18,000 only. That's actually not quite huge, or that's in a very I wouldn't say it's very small as well, it's very big. But in most of the documents, or when the user is going to ask a query, or most of the documents already have standardized templates, standardized. Isn't this standardized, sorry guys, my English is quite bad. Standardized um, wordings and vocabs, to be honest. So what you do is that you search among the 18,000 and then you pull it up. Now the issue is that, how do you search accurately for that 18,000? You have 18,000 stuff, right? You literally want to embed each of them, and then you would ask it as a question, and then you would want to do re-ranking, and everything has to happen in less than a second. Let's see how we can pull that off. Yeah, so I think it's writing the generic skeleton agent. So let's do it. The search document, get document chunks. Yeah, those basic tool calling for now. We're not focusing anything on much very complex here. Just a skeleton should work. Yeah. Answer generation, and then you have the vocabs here. Can answer with proprietary technology. Yeah. Yeah. Well, the thing is, Scott was suggesting something else, which was, it's the original approach the cloud was suggesting, said when you see LXP, you match it to the vocabulary and change the document. But the thing is, you can't assume things, you can't touch the originality of the document. You shouldn't. And that's very inefficient as well. So the other approach is to do fine tuning or doing RAG. Basically, it's RAG, guys. It's basically RAG. You're retrieving the right vocabs. That's it. Whether it's 10,000, 20,000, doesn't matter. And after a few thousand, it's the infra problem. It's not your rag problem. It's totally an infra problem. So this approach very clean. If stuff were to like every week or every month or something like that, we can actually update the thesaurus or the vocabs, and it should be updated. That's it. And of course, you can also index and keep a lot of, for example, if ISP were to hit a lot of times, I hope you can index it and give it more weights or something like that, where hitting or cache something or something. I'm not sure how you would do it in an embedding space, but yeah, you can probably uh, index some of the things that's already searched or already or mostly used in a given sense. So I've seen ISP a lot of times. Maybe it's used a lot of times. Or I don't know, but this has to be dynamic as well. We can't hard code here. So when the user comes in a semantic query, retrieve 5 to 10 most relevant. Okay, we into this. Okay, so yeah. So the idea was past NASA this was supplemented proportion specific terms, maybe 2000 to 3000. Yeah, that's more than enough. 2000 to 3000 is what we need. And afterwards, as I did mention, 3000 to 10,000 is an infra embedding quadrant sort of a computation, not a computation, like storage sort of problem, and not depending on drag. If you were to solve for the first few thousands, it should easily work for the next few thousands. And that's yeah, that's how it should work. Actually, content you can show the user terminology and all of this stuff. And yeah, you literally, I guess we can just download this. So let's see this text file. Oh, it's thing not found. Yeah, anyway, when we come to this, we'll come to this. There should be some updated. Oops, easiest to pass and load rich relationships. Okay, bonus NASA. Okay, the repo contains multiple NASA thesaurus taxonomies plus Python scripts to load the SOKs. 18. Okay, there's a GitHub. There's already GitHub. What we'll do actually, we can use that. You'll probably have some advanced. You can use it Python. Just call it up, and I guess you should pull all the text files. Thank you. Dictionaries. We have aerospace information. Yeah, so much good sources. Everything is free, guys. Just think about it. And yeah, this is what we want to do. Get in NASA thesaurus and maybe the acronyms dictionary from NASA Center for Aerospace Information. Those are the two stuff we need to do. Taxonomy, I don't know if we need it. We can still index it, but I don't think we need it. So we'll just skip that. Also, guys, we are not going to work on it right now. Of course, after we figure out the agent, but I still wanted to put it out there because I don't want to waste, because this process will take a bit of time and I just don't want to start just keep on wasting some time. So I thought I should talk about it and just plan things out, and then we can easily move on for the next one. So Cloud Power Agent from implements a conversational agent with streaming support and tool use. You're a Meridian expert, Meridian expert aerospace engineering system with access to comprehensive access vectors of the capabilities. Yes, okay. Cloud Power Foundation agent. Yeah, cool. I think I looked into the docs, and for some reason I feel this very complicated. So hopefully, yeah, I'll figure it out. Yeah, just get this. Yeah, Nash, just check. Just the latest one. Use the latest one. Let's use the latest one. And I think Claude models. I didn't use Claude models. I mean, I've been using Claude Code and Claude Chat, but not models for a long time. So just read the docs just to refresh. This models comparison. Yeah, we'll stick with Sonnet 4.5, more than enough. Yeah, use this info. names. So I'm just trying to get the entropy API. Okay, we have $3. It's okay, it's enough for now. All right, done. Okay, so I think this streaming tool calls, so basic skeleton is done. I'll just actually design the, uh, yeah, where should we start? Now we'll actually start with the plan. Like for example, given a query, let it plan, create notes, and also create to-do list and update to-do list. That's what we'll work on, right? So, yeah, so I want to manage the system prompt of the agent in a different file. Make sure you create a variable and import this to your code. So then I can actually replace it with what we got it, the one, the one we have right now, which was generated. And yeah, sorry, Megha Rocks. I'm not sure if I didn't get it. I didn't get any notification, so I didn't see your message. I'm just seeing it now in case it's in case you've already left the chat. I'm sorry about that. But where you can start is that so I basically started building agents for in the legal field. So there is no any there is no any YouTube video that I watch, or there is I didn't follow like the conventional thing. No, like when those new stuff came out, like there was no any resources. But right now I think you have a lot of YouTube resources. You have also you have resources like GPT, Claude. They are itself like they're probably like a good teacher for you. So I would recommend you if you want to start it, if you're very, I think you're familiar with this field, then that good. If not, it's, you know, you have some decent coding experience. What you can do is just start building stuff like basic chatbot, basic to do stuff, and but don't stay on it, you know. Just move on building something. Just look into some I'll just say you, like, once you know how to build agents and all, just go to YC and see what the list of companies, and find companies that you wanna take inspiration from and build just for education project. I'm not saying as a competitor. If you want, you can do that, but just in go to YC, they have very interesting companies solving real world problems most of the time. So yeah, just look into some whatever is interesting, try to see what they're trying to do, and try to, you know, build something that works on par with them, at least as an educational project. That's what I would say. Yeah, apart from that, yeah, just build. Yeah, I would say just build. Yeah, that's what I would say. System hunt. Cool. Yeah, very detailed system hunt. Focuses a lot of principles, but I also want to make note here. I want to I want to some notes. In future, I want to create personalities. No more. Also, I think you can see over here we had some good points. Agents thinking, I think, if I scroll up. Yeah, agents mindset, influence, agents mindset. Domain reasoning is already there. Agents approach, and goal is already there, but just add goal as well. But this mostly covers it. I just want to, you know, just change things up and see whether this will influence it a little bit more in our success rates. But that's okay. We've done it, and Yeah, so what I would do is that I want to connect our quadrant to it and just have one search. For now, just search document simple. You just put in file in a query, but I want to see how the what do you call because the search also should like you should also have good tools to it. Filter by timelines. Using better data. If you want to only read tables, your approach will be different. If you want to go through figures, your approach will be different. Sort of like that. So I'm just thinking whether I can do something like that. But yeah. Yeah. What tools does the agent have now? I think there's like two tools. Only two, I think. Search documents and get document chunks. Retrieve all chunks from specified document ID. Use this when you need to see. Yeah. Yeah, it's fine. All right. Now, our next goal is to, I've updated the system prompt. Make sure you check it. Our next goal is to fire off a few, domain specific queries that will actually let the agent search tools and search tools. Should blabbering. All right, next, connect the tools to the agent. I've also updated the system prompt. Make sure you take a look at it. Do not specify what is bad or good in the tools. Just give info on the tool only. That's it. You actually send the specific question just to see like this. I think we can specify a thinking budget to Claude. Just check the docs. How do you mention it? For example, there's just wasting a lot of tokens. Like use a sub agent for this because you can just get. I already changed the Mac tokens to 100,000. Make it so I don't think it's 100. Make the thinking budget to be 30,000. It wouldn't use all 30,000, but just adding it. Just giving as maximum amount of space for it to reason if needs. Only maximum will go more than not even I don't think it'll even go for 2,000 or 3,000. Set to randomly. Okay. I'm not sure if the context is good. Actually, I performed quite well because we only have very limited data, but I guess we hit a read limit. 30,000, 30,000, 3, 4.5, 30K. No, per minute is only 30K. So I was actually using Claude for Claude Console. I was using my API key, but they have, because I have a very limited credits or something. I only have 30K tokens to be processed every minute or something. Which as the token accumulates, it won't be enough. I have to wait for a long time. So I've got some credits on Foundry, so I'm just signing up for it. Yeah. 0.6B model, and because yeah, cool. Yeah, that's also have the initial. I would say I would just put this. Uh, what we have to do is that yeah, 12 component. Right, guys. Actually, it was prompting me to create a subscription, but the thing is, I already have Microsoft sponsorship. I've got some credits for my startup, so I just figured out that to put my not payment details, figure out how to use that. So yeah, so deployment is on progress. But look at this user tool, so until we get it right, we can use this. Make that 10. Yeah, so we know that is using the whole process is actually working. So I just want to, yep, I guess for the next few, maybe even today or tomorrow, we'll be just working with the terminal. So I'll be like, just make the logs even more better and bit prettier so I can differentiate between the thinking, the tools, calls, and etc. And keep it minimal. So, because we'll be spending a lot of a ton of time using just a terminal until we have like a basic version. So we'll go to the source. Yes. So, a couple of it seems like there's no quota for this sonnet, then it's high quote. Actually, it won't perform as sonnet. Yeah. Give it a try. Okay, it's giving us in coefficient quota. I don't think we can. I don't want to waste time just meddling with this. We'll just go by this. Just work with this, or we'll just add a label. Yeah, cool. I think the search is working. So search is being able to understand most of the above documents and etc. So that is okay. We'll just quit this. What we want to get it right is that I want to get this sort of plan. I want to get this full plan up, this understanding plan. So what I basically want is that um, I need to create a task list, sort of like a notes. Yeah, I'll just copy this. Now we can call it simulations. Yeah. Yeah. Okay. API API இருக்கா? ஃபார் எக்ஸாம்பிள் இப்போ க்ளவுடில் வந்து அவங்க 50K ஏதோ அது லிமிட் ஒன்று வச்சுருக்காங்க. அதில் வந்து க்ளவுடு கூட இப்போ நான் ஃபவுண்ட்ரி இதில் தான் எனக்கு கிரெடிட்ஸ் இருக்குது. அப்போ அது கம்மி பண்ணலாமா? பேர் என்ன? அது நான் சும்மா செக் பண்ணி கொண்டு தானே. ஆ க்ளவுட் எல்லா மாடல்ஸ் யூஸ் பண்ணிக்கலாம். அது சும்மா நான் செக் பண்ணுறதுக்கு தானே. ஓப்பன் கோட் நான் பார்க்கணும். தேங்க்யூ. ஸோ I was not aware of this. I think it's called open code. Let me see. So coding agent, free models included. Will be sure, give it a try. No, I was not aware of this at all. I don't use many tools, to be honest. I avoid tools as much as possible. This looks good. Okay. Sanjay, இது வந்து கோடிங் ஏஜென்ட் தானே? என்ன யூஸ் இது வழங்குதில்லை எனக்கு. இல்லை இல்லை நான் வந்து இது ஏபிஐ கால் பண்ண பார்த்துக்கிட்டு. ஓ, ஆனால் நல்லா தான் இருக்கு, பார்த்துக்கலாம். நீங்கள் தான் பார்க்குறீங்க. ஆ சரி சரி, தேங்க்ஸ். Actually, I should try this out. I'm very new for this. Cool. Anyway, yeah, so what I want to do is have notes, and I'm just thinking whether should I have the to-do list as a note or something like that. We can have the to-do list inside notes, and we can also have notes separately as well. So we'll just do this. First, I want to have the agent to have its own notes. Notes will probably be this. Like this. Then I want it to have its own, I want to have its own tools also as well. This. Sure. Both. So what we basically want to do is that initially this is all, I mean, we've not done it even, we're just trying to create we're just trying to create the initial skeleton, tool call code and stuff, like just basic stuff, and then we have ton of work to do. We have to cross merge between documents and do a ton of work. So this is just to get the system prompt right, and also get the notes section, to get the to-do list section, and etc. That's it. So I should call it investigation. I don't know why. The thing is, like, I don't want to hard code a lot of information. I want the agent to work on its own domain intuitions, but still we can give it info on what the nodes could be useful for, and then the agent should then decide what to add, what not to add, and then keep task lists and etc. We don't need to hard code, at least at this stage, saying key findings, this, that, and this. We don't need to hard code anything. The current thinking itself is already good. We just need to say notes is a space for you to manage all of your notes, put your internal reasoning or whatever that would be helpful for you, and tasks are the tasks that you can put, what you wish to work on an order, and also update them. And if you come update them, and complete them, and if you think that new things should be researched and stuff, put them, update the task with those new info as well, and keep that updated. That's just it. You don't want to influence a lot on hard code like key findings. Some of them, what do you mean? If there's no key findings, then what happens? You just have to know, just assume that we just have to generally tell notes could be a space for you to note important things or things down, and task lists to do that, and you should be able to figure out what to do, what to add, and what not to add. So we don't want to give the agent some template like context, what they need, hypothesis, and etc., because it'll just mess up. So it we could these are just, I mean, this is just one scenario, and other scenarios could be different. So let the agent decide. Notes is a place to save things, all important tasks, all new information, whatever, I mean, whatever a senior colleague would do. That's the personality we're trying to do. Second thing is the task list. Simple. Cool. I'm just trying to make it as generalized as possible. That's the overall goal. So, and this is one key, because, for example, see this, there's context, what she actually needs, the strategy, and etc. But for another test case, it was quite different. Like what happened, my initial assessment, possible causes I should investigate, and stuff like that. So you just have to be, we can't stick that to, like we have to make it as low opinionated as possible. Even Claude Code is like that, very low opinionated. So you have two tools to help you stay on your investigation. Scratch by the use of however you find it. Also, write your own reasoning, important find things. I don't think whatever senior colleague would jot down is not a good personality. Just read through the entire system prompt and update it. I don't think that is a good personality. Simple task list. Just check the entire system prompt and update the notes. I think apart from that, others should be fine. But yeah, give me your info. Once I confirm, you can make changes to the code. Good, update the system prompt. Yeah, this is very low opinionated as possible, so should be fine for now. All right. Actually, I think you also should make changes to the code. Make sure to have a tool to create notes and a tool to yeah, create or update tasks. Actually, I would say just for notes. Make sure you have a tool for notes and tasks and manage them in a simple text for now, like in memory for now. And make sure to pass them throughout each uh, yeah, throughout each conversation or API call, whatever. The agent should need to would probably need to know the context at each stage. If now it replaces the previous state, even if you have a long note, it needs to rewrite the entire thing, but it's okay for now. Later we can do all the efficiencies, like I'll just giving ideas to update and etc. All right, so I also want to see them accurately when I test it on the in the terminal. So initially, whenever a task or a notes or the notes do change, you should probably show it to me on the terminal. So I actually verify whether what's really going on. Do not truncate anything. Just show me all the nodes, all the tasks. All right, so I also want to see them accurately when I test it on the in the terminal. So initially, whenever a task or a notes or the nodes do change, you should probably show it to me on the terminal. So I actually verify whether what's really going on. And we'll also make sure the max iteration for an agent. Do not truncate anything. Just show me all the nodes, all the tasks. API queries. All right, then you can see the notes. All right, so I also want to see them accurately when I test it on the user context in the terminal. My initial hypothesis. Initially, whenever a task or a node investigation task find Euro or the nodes do change, you should probably show it to me on the terminal. Do this, do so that. So actually verify whether what's really going on. Analysis phase, understand what terminal issue and why. That's why I was like, we should never hard code values. Now, analysis phase is something that we didn't even specify. But it just thought that you probably have to have it in the tasks. So that's why you just try to find that sweet spot where it'll also understand that phase. And this is HiQ, by the way. If it was Opus or Sonnet, then do not truncate anything. Just show me all the nodes, all the tasks. It's cheaper for me. Plus, you'll get something working for a low intelligent model. Thereby, if you were to just upgrade the model, you'll have a better intelligence right off the bat. Let me try searching specific terms and just searching specific terms. All right, then you can see the notes. All right, so I also want to see them accurately when I test it on the user context in the terminal. And my initial hypothesis. Initially, whenever a task or a node investigation task find Euro or the nodes do change, you should probably show it to me on the terminal. Yeah, the thing is that this question is actually verify whether what's really going on. And understand what terminal issue and why. That's why I was like, we should never hard code values now. Yeah, analysis page is something that we didn't even. The question is very different, right? And just thought that and the document have it do exist is very different. So that's why you just try to find that sweet spot in searching where it'll also understand that phase. And this is HiQ, by the way. See that was Opus or search results so far. Initial search not truncate anything. So we'll work with HiQ. All the nodes, all the cheaper for me. Plus, you'll get something working for a low intelligent model. Thereby, if you were to just upgrade the model, you'll have a better intelligence right off the bat. My next approach, try search for specific thermal distributions. Search for meridian reports and notes. Look for thermal specification. All right, so I also want to see them accurately when I test it on the context in the terminal. My initial hypothesis. Initially, whenever a task or investigation task or the nodes do change, you should probably show it to me on the terminal. Yeah, the thing is that this question is actually verify whether what's so we'll do is we'll be like thermal issue and why. That's why I was like, we should documents not, we should that do exist code values now. Yeah, analysis database is quite different. The question is very different, right? And just thought that and the document have do exist is very different. So that's why you just try to find that sweet spot in searching where it'll also understand that phase. And this is HiQ, by the way. See that was Opus create a query that sort of works. Not truncate anything. Just work with HiQ. All the nodes, all the cheaper for me. You'll get something working for a low intelligent model. Just put this. Thereby, will be related to thermal analysis upgrade the model, you'll have a better intelligence right off the bat. My next approach, try search for specific thermal distributions. Search for writing reports and notes. Look for thermal specification.
All right,
Search
so
for
I
initial
also want to see
verification
them
table, search for
accurately
specification thermal
when
margins.
I test
I
it
think
on
this
in
was
the
the notes
context and
indeterminate.
my initial
So
hypothesis.
initially,
Usually,
whenever
whenever
a
replace the
task,
task
you can see it's
a
replacing the entire
investigation
notes. You can
task
see, right?
or the notes
That
do change,
basically
the
search
computer
for
probably show it to me on
terminals.
camera.
Yeah, the thing is that this question
So
is
I
very
actually
different
verify
here.
whether
So
what
what we'll do is
and
that
answer
I'll be
what
like terminal issue and
uh,
why. That's why I was like,
Embeddings
we should not,
documents
we should
that do
never hard
exist.
code
So I
these
think
analysis
our
page is
database
something
is
like
quite
the question is
nuanced.
very
So we
different, right?
needed
And
this initial
thought that
hypothesis,
you
and
probably
then
have
to
to
have a
do it
search
just
strategy.
strategies. So
And
that's why
task,
you
now
just
I
try
took a lot of
to
work
just
going
try
into
to find that
concepts,
sweet spot
still
where it'll
and with the
also
different
understand the
perspectives.
space. And this is
It's
nice
nice
to see that
I'll
so far you
I'll
haven't
create a
also
query that
sort of
so
worked
not
through
truncate
and
that thing. So
so
you
far
know,
it's like
all the nodes with
it's
this
cheaper for me
to
to get
something
something
working
working for a low,
and
particularly
then
the
I'm
model
just
just
put
design
this
criteria
or
thereby
questions
to
to
do
upgrade
exist
the
a model
model
and
and
have a better
what's
excellent
not
found key
working.
document thermal analysis.
My next
I'm seeing
approach,
table
try
4
search
if I
for
check the key
specific
definition of
thermal
pieces
distributions.
get a
Search
detailed
for
content on it. Now what you can do is that now because now right now we
all
just have
right,
a
so I
search
also want to see them
work
accurately
population and tables and
when I
etc.
test
I
it
think
on
this was
the
the notes
even though
the tables are very much quite
so
scanned and everything
initially
shows
whenever
replace
a
the
task
still end up with replacing the entire
investigation
task because you don't have like
or the
I
nodes
need
do
to
change,
I wanted to have
computer probably
specific
show it to me on
terminals
screen.
called tables and
So I actually verify
they
whether
can
so we'll do is
metadata can be like more properly used up. So
for
that's
now
why
it's okay.
I was like, we should not
Documents
whatever
that
do
do
exist
exist
in the
in
basic level. Analysis
our
page is
database
something
is
like
quite
the question is
nuanced.
very
So
different,
we
right?
needed this initial
I think it's
hypothesis,
something that
and
probably
then
have
to
to
have a
do it
search
just
strategy.
strategies. So that's why you just try to find that sweet spot where it'll also understand the space. And this is nice to see that so far you
So
haven't
create a
also
query that
sort of
so
worked
not
through
truncate
and
that thing.
so
So
far it's like
all the nodes
it's
with
cheaper for me to get something working for a low,
and
particularly
then
the
I'm
model
just put
design
this
criteria
or
thereby because it that do exist a model and have a better excellent found key document thermal analysis.
my next
I'm seeing
approach.
table
Try
4
search
if I check
for
the key definition
specific
of
thermal
pieces let me get a
search
detailed
for
content on it. Now what you can do is that now because now right now we just have a
so I
search
also want to see them accurately
population and tables and
when I
etc.
test
I
it
think
on
this was
the
the
context
even though the tables are very much quite
so
scanned and
initially
everything
whenever
replace the
task
still end up with
investigation task
because you don't have like
or the
I
nodes
need
do
to
change,
I wanted to have
computer probably
specific
show it to me on
called
screen.
tables and images
So I
are
actually
different
verify
they
whether
can
so we'll do
those
is
metadata can be like more properly used up. So for
that's
now
why
it's okay. I was like, we should not
documents
whatever
that
do
never
exist in the basic level. Analysis
our
page is
database is
something like
quite
the question is very
nuanced. So we
different, right?
needed this initial
I think it's
hypothesis,
I think
and
it's
then
sort
to
of
have a
describe
search
it
strategy.
so that's why you just try to find that sweet spot where it'll also understand the space. And this is nice to see that so far you
So
haven't
create a
also
query that
sort of
so
worked
not
through
truncate
and
that thing.
so
So
it's like
all the nodes with this
cheaper for me to get something working for a low, particularly the model design criteria thereby because it that do exist a model and have a better
I would say we need to add the context about the tools that are available for the agent in the system prompt, probably in some section, probably end or something like that, where we specify and tell if you were to just give it some extra information, because right now the tools description itself won't be that much enough. So it's better if we have it in the system prompt. try this. Done. So let it run. I'll come back in a minute. All right. Let's see. So it did find a bit of information. Let me update my notes in specific chemical, which has external data. So investigation notes, key finding, fundamental research is transfers. Messages. So the thing is like this, you won't update the notes. Like if, for example, even if you write the notes, you don't clear stuff and write back, right? Like you don't do it. You don't start. So I'll just note it down. The notes seems to be okay, but usually even if you were to write any notes, when you come across new information, you don't like delete all of the past notes and write new stuff, right? You'll keep that and also, but you'll add more information in the next page or something like that. So fundamentally, this notes should have some information. Anyway, I'll just think through this. Let's just run out right now. Right, this is okay. It's missing to update the searches as well, but we'll figure this out. But okay, this is a very good. I would say today we didn't make that much of progress. Just a minute. இது கொஞ்சம் சொல்லுங்க sir. So yeah, head to head that, guys. I'm gonna stop the stream. I'll maybe come back and continue. But yeah, the next stream what we're gonna do is that we'll probably have to just spend a little bit of time on this and get the plan and all of this stuff working. Danish, sorry, sorry guys. All right, we'll see you soon. Bye. We'll continue on the next. In yeah, next we'll probably be working on the rest of the agent and working on the yeah, we'll be spending a lot of time on the tool calling and getting the like the in like this the base agent working, right? All right, see you.